ड्रॉ करना है, राइटिंग चलेगी, राइटिंग नहीं हो रही। दूसरा
ऐसे इसको ऐसे यूज करना, बटन प्रेस नहीं करना, इसको टाइम लगेगा, वेट कर, दूसरा ऐसा दूसरा
कितना वेट करें? Okay, we'll start the session within 5 minutes. I am writing here few IP addressing. So I would like to ask the remote centers among these 5 IP addresses, which one are the IP addresses? क्लोज करके दोबारा चलाइए, क्लोज करके दोबारा चलाना, सेशन क्लोज करके दोबारा चलाइए। क्लोज कर दो, सेशन बंद करके दोबारा चलाइए। ठीक है, नेक्स्ट माउस।
कभी इसको यूज करना है, देखो ऐसे कुछ नहीं, ऐसे यूज करना है, इस पे हाथ धरोगे चलेगा नहीं, इस पे ध्यान रखना है, इस चीज पे बिल्कुल भी हाथ नहीं लगाना।
थोड़ा हो जाएगा बोल्ड ऑप्शन, एक पेन दे दो बस बना के, थोड़ा बोल्ड कर दो, आ नहीं रहा क्लियर कलर। Now today's topic is on IP addresses. I have written here 4 IP addresses: 300.400.500.600. Another number I have written here 3631443189. And third I have written here D8736C5 CF5. and fourth I have written here 1.1.1.1. Now I would like to ask the remote centers as well as the local center. Among these four IP address, which one is the IP address? So we'll start from Tamil Nadu. Among these four IP addresses, which one is the IP address? Hello. Second center, CV Raman Engineering College, Bhubaneswar, Odisha. I have written here four IP addresses. Which one is the IP address?
Hello, this is sir. Good morning, sir. This is Prasad from STC University.
Can I hear?
Sir, can you hear me, sir?
Yeah, we can hear you. Can you repeat your answer?
The fourth is an IP address.
Answer Inka.
Four.
Can you repeat your answer again?
Four, sir.
Fourth one.
Fourth one. Okay. I have written here four IP addresses. Which one is the IP address?
Fourth option, sir. Answer four.
What about option 1, 2, and 3?
Sir?
What about the options which are written at number 1, 2, and 3? Are they IP address or are they not the IP address?
Fourth will falls under IP version 4 IP address, and remaining it won't be considered. And most probably third will be maximum. I don't know whether it will be compatible with IP version 6 or not. But fourth is IP version 4. Let go IP version.
I'm talking right now. I'm talking only about the IP version 4.
Okay, then it's fourth.
Later on, yeah, only IP version 4, and later on we'll talk on IP 6 if time permits. We'll do the implementation also.
Then it's fourth. Fourth is an IP address.
What about okay? Next center Noida, we have the constraint of the time, so I'm asking fast. Other remote center Noida. I'm asking the same question from all the remote centers. Just mention me among these four IP addresses, which one is the IP address. So I'm asking the same question from the Noida center. Next center is Moradabad, then Indore, then Garhwa, then Jodhpur. So I'm coming one by one to all remote centers.
Hello?
Yeah, we are hearing you.
Yeah, sir. Fourth one is the IPv4 address, and the rest of the three can be IPv6 addresses.
I am repeating again. Right now, I am not talking at all of IP6. I am talking only of IP version 4.
Then it's confirmed it's version fourth one, sir.
Okay, I'm moving towards Moradabad, MIT Moradabad.
Sir,
Mr.
I am from MIT Muradabad.
Okay, so your answer is number 4 only. Okay,
Yeah,
what about the answer from Noida center? Is it online?
Hello?
Yeah, we can hear you.
Yes, sir. Answer 4. What about option 2? What you have written? 36314443/89.
Yeah, 3189. I have written here and some random numbers. I have written here 4 numbers and I am asking the question which one is the IP address. Now next I am moving towards Indore center. After this I am going to ask from the Chandigarh University. So from Indore, can you reply this answer?
So from Chandigarh University, fourth one is the IP version 4.
Okay. From Jodhpur.
Only answer number 4 is correct because it is between 0 to 255 and there are 4 of them, so it is correct.
Okay, and from Jaipur or from remote center Chandigarh, which one is the correct one? Only 4. So all center has replied that number 4 is the IP address, but for your information, all are the IP addresses. All are the IP addresses, IP version 4. I'm going to show you this practically now. So shall we? I'm going to start the session. In this session, I will talk about the type of classes, type of versions, and what are the different forms of IP version 4. So I'm going to use both this board as well as a presentation. So I will keep on switching. So we left with 1 hour for this session. So I will be a bit fast. So as I asked you what is an IP address, so this is a kind of address that identify the network location, and all the IP addresses which I have written on the slide, all are IP addresses. And there are two type of versions. So first we'll talk on the version number 4, then we'll talk on IP version 6, and if you again see the latest current scenario, IP version 7 is also in the picture. So what is the role of IP address in any network, whether it's wired network or wireless network, or maybe on sensor network, radio frequency identification devices, or mobile phones, or sensor based, or router servers, wherever we have to have some kind of addressing for the communication purposes. So there are 4 type of addresses are there. This is one type of address that we are going to talk today. So what is the role of this? It will identify the sender and the receiver. It will determine the network location, and it will support the routing tables and decisions. So after this session,
What are the
all the
4
remote
type of
centers.
addresses?
Pardon?
TTR Jodhpur, what are the 4 type of addresses you said?
I asked one question, and on the board I have written 4 addresses randomly. If you want to see again, you can
No,
see
sir.
here.
No, I am not asking that. You said there are 4 type of addresses and we will discuss them today.
Okay, I got it. I got your very good. Just one second. Whenever we have to do communication, there are 4 type of addresses, and one type of address is the IP address. So any remote center would like to reply on this? What are
Maybe
the other
MAC
type of-
address is another address.
Exactly, one is a MAC address, also known as hardware address. Second one is IP address 2. Number 3, port address. Number 3 is a port address, and ports are of 16 bits. So there are approximately 2 to raise power
65,536.
6,000. Yeah, exactly 65,536. So that is the third one, and fourth address is your computer name. If there are certain protocol which can work without, that can do the communication without TCP/IP model. Can you name that protocol? In that scenario, only we require the computer name. That protocol name is NetBUI. Nowadays it is not in use, so that protocol is known as NetBUI, Network Basic Extended User Interface. So I am repeating again. Those 4 addresses are IP address, MAC address, computer name, and fourth one is a port address. So based on these, we can do the communication. So IP address, when talk on the IP address, especially on the IP version 4, it's of 32-bit binary bits, whereas in IP version 6, it's 128-bit binary. That will also come in the consequent slides. And these 32-bit binary are further divisible into 2 portions, network portion and the host portion, and that is divided on the basis of the subnet mask. So we'll see one by one. So there are 5 type of classes are there, A, B, C, D, E. Now I am writing here how these classes are being, how we can identify. Whenever we get any IP, we can identify easily whether it belongs to class A, class B, class C, or class D. As I told you, it's of 30. That means,
Sir, this is from JIT Jodhpur.
you are not getting my voice. Can you check your bandwidth? There is a one website where you can check your bandwidth. There could be a bandwidth issue, or there could be some other issue. If the bandwidth is too slow, you will not get voice in between sometimes, or it may become in that forms of kind of breaks you will find.
Sir, you have to mute some of the participants.
I hope every participants have hear this request. So kindly, I request again, kindly mute your mics. So let me describe for another 20 minutes, then we'll have discussion, then again 20-30 minutes we'll do, and when we have discussion. So for the time being, for another 20 minutes, I request all the remote centers to kindly keep mute their mics. So in case if still you get any problem, you will get the recording, you will get the presentation, and there is a one website where you can check your speedtest.net. So I am writing here, we have, let's say, we have 32-bit binary, which are further defined in the 4 octets. Now this could be any form like this 8. Similarly 8, I am writing here simply 8 bits, 8 bits and 8 bits. So we will concentrate on this first octet. We will concentrate on this first octet. So we have 32 bit. We have 32-bit binary address, which is further classified into 4 octets. Octet 1, octet 2, octet 3, octet 4. All are of 8 bits, 8 bits, 8 bits, 8 bits and 8 bits. So we will concentrate on the first octet. In case of class A, the first bit, that is 0, is reserved. In case of B, bit 10 is reserved. In case of C, bit 110 is reserved. In case of D, 1110 is reserved. And in case of E, 1111. Again, we'll see what is the meaning of this reserved bit. So in case of class A, the first bit 0 is reserved. In case of class B, 1 and 0 is reserved. In case of class C, 110 is reserved. In case of class D, 1110 is reserved. In class E, 111 is reserved. Now we'll see class A. As I told you, 0 is reserved. So minimum number will be 0, 0, 0, 0, 0, 0. 7 times 0. 7 and 8. And remaining will be dot some other numbers, dot other octets. So I am talking about the first octet. Remaining number could be anything. So in class A, the number will be 0 will be reserved. So next number will be, what will be the next number? 0, 0, 0, 0, 0, 0, 0, 1. And in this way, the maximum number, the last number will be, what will be the last number? 0, all ones. Got it? So that means 0, this 0 is reserved. In class A, this number will be reserved. We cannot change it. So this will be the minimum number, this will be the maxi number. If we convert into decimal value, what will be the value we'll get here in class A?
127, 0 to 127.
Exactly, 0 to 127. And how to convert this binary to decimal? We have 3 ways. Many ways are there. First, we can use a calculator. Second, we can do the 0 into 2 to raise power 0 binary to decimal. Or third way, we can have the weightage system. So I'm going to explain the weightage system. So the bit 1 will be have the weight 1, 2, 4, 8, 16, 32, 64, and last will be 128. So wherever there is a 1, we will add that weightage. So if you see the last, so we have to add 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So when we add this, we'll get the range 0 to 127. Okay, still there is bit confusion. I am repeating here. In class we get 0 to 127. I am repeating here. So how we get this range? Let's say I am giving here one random value 0, 0, 0, 0, 1, 1, 1, 1. What will be the decimal value for this?
15.
So how we get that 15? As per the weightage system. So we are starting
There
from
is one shortcut trick. If there are all ones, then 2 raised to number of ones minus 1.
okay. If I give here 0, 1, 0, 0, 0, 0, 0, then what will happen? Now what will be the value now in this case?
2 raised to 7.
Okay, 2 to
120. No. 2 raised to 6. 2 raised to 6.
if I give here some, let's say here I have given here 1, then here 1, then what will you do in that case?
Then we will have to use your method.
Which method?
Adding those weightage.
So which one method is better and accurate?
So it depends on the binary number.
Yeah, as I told you, you can do the binary multiplication, or you can use calculator, or you can use a weightage method. So I am explaining here weightage method. So in this weightage method, we have the 2 to raise power 0, then 1, 2, 3. That in this way it will increase 8, then 16, and so on up to 2 to raise power 7, 128. In this scenario, we have all ones, so we will add those numbers. So it will be 8 plus 4 plus 2 plus 1. Got it? So output will be 15 in this case. In this case, the output will be 15. Similarly, in the class A, the first number was 0, the remaining one was the last 1, 1, 1, 1, 1 all. So when we add those weightage, we'll get the A range 0 to 127. So that means the class A range start from 0 to 127. Now we'll talk on the class B. So in class B, what will the minimum number? So reserved is 1, 0. So what will be the minimum number here? And what will be the maximum number here? What will be the maximum number here? 1, 0, and all will be. If we convert this into decimal, what will the output will get? So output of this will be 128, and output of this will be weightage of this plus this plus this plus all ones. Then we'll get the output will be, I think, 191. 191. Similarly, we'll get for the C, D, and E. I hope all the remote center got this concept. So shall I explain for C, D, E, or shall I skip that? Okay, I will explain for the class C, then we'll see. So in case of class C, the reserved bits are 1, 1, 0. So minimum number will be, and the maximum number will be 1, 1, 0 will be constant, and remaining will be. If we convert this into so it will be around approximately 198, 128. The weightage will be here of this bit will be 128. The weightage of this will be 64. When we add this, we'll get the 192. And here it will go up to 223. So in the same way, we'll go get for the D and E. In this way, we get for the classes for A, B, C, D, E, the range. But in addition to that, there are 4 rules are there. Now see here. In addition to that, have the 0.0.0.0 for the computer or the this IP address. This is reserved for the network address. This is a rule number 1. Number 2, we cannot use 255.255.255.255. This is reserved for the broadcast. This is reserved for broadcast.
एमएमएम बुलाना कैन हेलो
हेलो
एमएमएम बुलाना
हाँ सर इट्स ओके
सर अपना माइक को म्यूट कर लीजिए प्लीज
ओके सर
Now, for another third rule is that we cannot use 127.0.0.1 series because this is reserved for the loopback address or for local host or for standalone machine. Now, what do you understand by loopback? The data which is on the computer will not traverse on the wire. Even if you connect two machines with a direct, data will not go from over the cable. So that is only for the standalone machine. And the fourth rule is about the private address and the public address. Somehow this pen is waiting for certain operation. So right now it will take another 2 minutes. So meanwhile you can see the presentation. So 0 is reserved for the default route or for the network address. So because of this reason, the range will be from 0 to 127. The range of class A will be always in between 1 to 126. Why again this problem is there? Because 0 is reserved for the default route or for the network address. 127 is reserved for the loopback address. So we will have this number of networks, and when we talk again on network portion and host portion, we will describe there. So how these figures came: number of network, number of host. So this is reserved for loopback. So in class B, the range will be from 128 to 191. So this will be the number of networks, number of hosts. In class C, the range will be from 192 to 223. Number of networks and the number of hosts will be these. In class D is reserved for multicasting. So the range is from 224 to 239. It is reserved for multicasting. And class E, that was for experimental, for streaming purposes. It was underdeveloped. Then in between IP version 5 came. So they found that in future there was some limitations of the class 4 in terms of the number of IPs, maximum number of IPs. And nowadays if you see, lot of applications are there like IoT, are there Internet of Things. Then not only the computers are using nowadays these IP addresses, but it is also being used by many machines like refrigerators, washing machines, vehicles, and etc. etc. So they found the limitation of this class, and they were handling through classless subnetting. But in between, when they were doing experiment with IP version 5, then they thought of a good number of range. Then they came with the IP version 6. And again, as I mentioned, now IP version 7 is also in the picture, because there were certain limitations they found in IP version 6. So fourth one is about the IP address, private IP addresses. I hope now this may work. So I'm now using Notepad. So what are those rules are there? Zero dot zero dot zero dot zero. This is reserved for broadcast. (127) series. So I'm writing any number starting with 0 series, reserved for loop back address. Number 4th, we have private IPs and global IPs or public IPs. Now, but don't understand my private IP and public IP. We can relate this example with the telephone number. So when we have phone number, we have internal number and external number. Internal number may be of 3 digit like 579, 520 like that. So those are known as private number in case of IP addresses, and remaining if you have 6 digit or 7 digit depend on your city location, it will be public IP. So through private IP you cannot communicate with any external number, real number. So for that you have to depend on the exchange. Similarly, when you have to do communication over the internet, you have to depend on the netting or proxy server. So we'll see for the private addresses for A class A. So in the presentation, this is given here 10 series. I am writing here 10 series. Class B 172.16 to 172.31 series. In class C, we have 192 series. Other than this, whatever you will find, you will get all those IPs are public IPs. In addition to that, one more IP series is reserved for APIPA, automatic private IP address. Now, whenever you have to configure your device or your mobile device or your mobiles or any device, you have two methods: static IP and dynamic IP. Static IP or automatic private IP address. Automatic private IP address, dynamic from DHCP. So you will find even in your organization you might be running DHCP server, and your mobile device or mobiles or your laptops, they may have get the IP address automatically. So that automatically is nothing but you are getting the IP address from a server that is known as DHCP server, dynamic host control protocol server. And sometimes let's say you are trying to get the IP address from the DHCP server and DHCP server is down or not available. At that time you will get this series 169 dot series, this series. So this you will see in the presentation also. So what I mean to say, you have the private IP and public IP, though for class A 10 series, class B 172.16 to 172.31 series, in class C 192.168 series, and one more is there, APIPA. So the range for this is 169 series. Other than this series, all are your public IP address. So you will see again in the presentation. So we have the IP addresses typically used on our local area network. And when we have this private IP address, we cannot transfer our data over the internet. Sometimes we have seen some people, they are hosting their web servers or their mail servers, they have configured everything, but still they are not getting their website outside from their organization. So what is the main problem? They might have set up everything on the private IP. So you have to take this global IP from the ISP, internet service provider. Then only the people can view your content from the outside of your organization. So the range of this IP address is 10, as I mentioned you, 10 series for class A. For class B 172.16, and then further onwards till 172.31 series. Class C 192 and 168 onwards. So you will see similarly in your organization, you might having any one of these series. So we are using right now two kind of series. One is 192, 168, another is 172.16 series we are using for our own local area network or private IPs. Then in addition, we have this result for the APIPA address 169.254. something something. Then we have the network masks. Now these network masks are further classified into two categories, classful and classless. So classful are known as default network masks. For class A, the network is 255.0.0.0, and for B 255.255.0.0, class C 255.255.255.0. So this is for class A, this is for class B, this is for class C. So based on the subnet mask, we will come to know about which portion is the network portion, which portion is the host portion. So whenever the two computers they want to communicate, network mask should be same. Otherwise, they will not be able to communicate with each other. And how the subnet mask come in the picture? It will do the AND operation with the IP address, given IP address. For example, after time waiting, और दे दो दूसरा पेन ब्लैक वाला, इसमें ट्राई कर लेते हैं, ट्राई कर लेते हैं। ये स्क्रीन दे दो, टच स्क्रीन दे दो, टच स्क्रीन। प्रॉब्लम है? कुछ लिखना है आपको। अपने आप में कोई भी आईपी लिख दो। So on my behalf, Mr. Feroz is writing one IP address, and now this belong to which class? This belong to class C. And in class C, what is the default subnet mask? 2.255.255.0. So लिखना इसके नीचे 2.255.255.0. 255.0. मैं लिख सकता हूँ, चल जाएगा इसमें लिखना तो ऐसे लिखना दबा के। चलो ठीक है, चलो ठीक है, okay. Now we have written here one random number and we have written the default mask. So now in the next slide of this we will see how to do the binary operation. So next में जाना, next page. Now we are not writing the exact binary, just for your understanding I am writing randomly one binary, कोई भी लिख दो, 110 110 110 11 3 4 5 6 7 और एक 0 के साथ। Now let's say this is one IP binary we have got from the any IP address, and subnet mask, as we know, it's 255.255.255.0. So 0 means all bits will be 00000 8 times, and 255 means all will be ones. Once लिख दो सारे इसके नीचे. Next one. वो लिखो. End operation. Next one. और 8 से किधर नीचे 1 1 1 लिखो. Notepad में. So for one octet, I will show you how this binary AND operation will take place. इसके नीचे line लगा दो. Now, as we know, we have OR operation, AND operation, and NOT operations are there. So AND operation means 1 and 1 will be 1, 1 0 0, 0 1 0, and 0 0 will be 0. So here, wherever you will find 1, you will get the 1 output. यहाँ पे 1 from यहाँ से शुरू करना. So when we do the AND operation, 1 will get the 1, we get 0, 1, 0, 1, 1, sorry, 0,
0.
again 1. So if you see the output, this output is same as the input. यहाँ पे जैसे ये on the first line you have seen 1 0 1 0 1 0 1 1. When we do the AND operation with 1, we'll get the same output. So that means when we are doing 192.168.3.1, when we do AND operation with 255 255 255, so we will get the output as a 192.168.3.0. So that number will be the network, and 0 means host portion. ऐसी कोई भी IP address 192. 168, 168, 20.5, और नीचे लिखो 255 255 255.0. So when we do the AND operation with this subnet mask, we will get the output 192.168.20.0. ये रहेगा 192.168.20.20.0. ये लिख दो 192.168.20.0. So when we do the binary operation, and again when we convert this into decimal, the final output will be in this form. So 0 means host portion. I hope it is understood by every remote centers. Now we'll see in the presentation. So this is a unique identifier for a node. So all two computers cannot have same IP address. And if you do assign static same IP address, it will start giving conflict between two machines. So it is a 4 decimal values which is represented as a 8 bits. Total will be 32-bit binary, and the range is in between 0 to 255. So this is one example, 140.179.220.200, and the binary value is this one. And when we do these are the address classes A, B, C, D. This is reserved for the multicasting class E, and then with the help of ping command we can do these operations. So now I have written here 10.9.8.1. So it belongs to which class? So by seeing the first 8 bit, we can easily identify whether it belongs to A, B, C, D, or E. Similarly, we can do with other IP addresses. Now we'll see how the class determined by default which portion is the network portion, which is the host portion. So we have 32-bit binary number, range in between 0 to 255. So for class A, that default subnet mask is 255.0.0.0. So that means the first will be network, remaining portion will be host portions. So similarly with the class B and similarly with the class C. What about class D and E? Any participant who want to reply for class D? Which portion will be the network portion, which will be the host portion? So class D and E are reserved for experimental and multicasting. So there is no such scenario of network and host portion. So if we see this belong to class B, so what will be the network address? 140.179.0.0. And what is the importance of this network address? Let's say you are running. Now we'll see the practical example application of this. Let's say you are running two ranges, 168.1.1 series, another series 192.168.2 series, and you are running another one 192.168.3 series. Let's say this is for your students, and this is for your teachers, and this is for your HODs or principals. This is for your HODs and principal, this is for your teachers, and this is for your students. Now all of you are now the network engineers and network experts. So there is a requirement that students should not access Facebook, YouTube, etc., etc., etc. So what policy you will put in your proxy server? Simply in the policy, depend on the firewall, maybe a Cisco ISA or some UTM, or maybe open source proxy server. You might be using Squid proxy server or any. Just you have to simply say allow and deny. So in the policy you have to say deny Facebook, YouTube, and etc., etc. websites. To whom? Students. Whereas your teachers, where your HODs can access the YouTube, Facebook, etc. So what you will put in your policy as a network address? So simply, question is clear, or shall I repeat the question? Okay, I'm repeating the question. There are three series in your network. You have given these series. One is for the HODs or guests, second series is for teacher community, third series is for students, and the requirement is that students should not access Facebook, YouTube, etc. So simply in your policy what you will say, deny this network address 192.168.3 series. Simple. So how you will represent this as a network address? In this way. Now I request kindly mute your mic. So kindly in your policy, just you have to put deny Facebook, etc. for the series 192.168.3.0. And if you want to control particular host, then you have to specify a single individual IP address. So this will be applicable for the all IPs which are in this range 3.20, 3.30, 3.40, etc. It will be applicable for all the IP addresses. So this is the important of the network address. So in this way we do the subnet masking and the AND operation, and through that we'll get the output. So this is one example. In this we will get the network address So this belongs to class B. This is a binary. This is a default subnet mask. When we do the AND operation, we get in this way. So these are the default subnet mask for A, class B, and class C. So now can you calculate the network address and host address in this case? So this belongs to class A. So it will be the network address 1.0.0.0 and host address will be in this way. Similarly, we can find for all range. So if you see the last series 192.168.10.0, default subnet mask is 2225. So the network address will be 192.168.10.0. So in the same way we can find out for other series. So this is a kind of tree of IP addresses. So these are the rules or some facts. We can never use 0 series, 2550 series. We cannot use the network address series, and we cannot even use the subnet mask as a IP address. And two different network IP address cannot be communicate. But on the internet, that is not the scenario. There are always two different network addresses are there. So there there is a requirement of router. If we have to communicate among two different networks, then we have required a router. Unique IP address has to be assigned to the network. So in the practical scenario, in this way we can go to the control panel, TCP/IP properties. There we have two options. There we have two options you can see here. One is about the IP address automatically, that for this you have to depend on the DHCP server, or you can assign manually or statically. So here you can see this is the IP address assigned to the host machine, and this is a subnet mask, default subnet mask. And then there is a command ipconfig/all. Through this you can see your not only the IP address but also you can see your MAC address, physical address. So when you run this ipconfig/all, it will show all the IP addresses. Now another question: how many IP address we can assign to one machine, or how many IP address we can assign to one LAN card?
Sir, for one machine we can assign multiple IP address, but for one card we can assign only one address.
Let's say I have two LAN cards. I have two LAN cards in my machine.
Then
So
you will have two MAC addresses, and then two IP addresses can be mapped to the two MAC addresses.
And if I required 10 addresses, then what I have to do?
I guess you will need 10 different MAC addresses,
You mean
10 network interface cards.
You mean to say 10 LAN cards we required for 10 addresses?
Guessing, sir.
But if you see, the motherboard can support only maximum 2 to 4 LAN cards. And if you are running your hosting company, you have to host hundreds of these websites, and each website has to be configured with the IP address. So machine cannot afford 100 MAC addresses or 100 LAN card for 100 websites. So I will show you practically also just now, because we left with I think 10 minutes. So I'm skipping some of the presentation. Now I'm going for the practical part. And here we can have n number of IPs to a single LAN card. So for single LAN card we can assign multiple IPs. There is no issue. Because when you are running web server, mail server, proxy server, squid server, DHCP server, FTP server on a single machine, you require different IP addresses. So for these 5 to 7 servers, you cannot afford 7 MAC addresses or LAN cards. So we'll see now how we can assign multiple IP addresses to the same machine. And with the ping we can have. Then we have certain limitations of this IP address, and for this we have to go for IP6. So let me finish now practical, and if time permits, I will show you the IP6 also, how we can give us practically IP6, how this IP6 get automatically, and this is much easier than the IP version 4. IP version is bit difficult, or we can say complex, but in IP6 it is much easier. Once you understand the concept, you will definitely go for IP version 6 implementation. So I'm stopping the presentation here. Now I'm going to show you the practical, whatever we have talked, and then again we'll talk on those IP addresses which I have written on the first slide, how we can get the different forms of the same IP. Now for this practical implementation, I'm going to install Windows operating system in this. How many operating system we can have on one machine, or how many operating system we can run at the same time? So right now I am running Windows 10. Inside this I am going to show you another 2-3 windows we can run at the same time. So for this I am going to use a technology, virtualization technology, virtualbox.org. You can get from this website, from the Oracle virtualbox.org. Download it. I have already downloaded. Now I am installing right now. Then I am going to install the operating systems. I will show you 3 operating systems and the communication among that. Now this is ready. So I'm going to make a new machine. So when I say new, it will ask me which operating system you want to use. Solaris is IBM OS, Mac OS, or variant of Linux. So I will say Windows. Then again it will ask me which Windows. Windows 10, Windows 2012, or Windows any server. So I'm going to use Windows XP. So I'm going to write here any name we can give, XP. How much RAM we want to give? So I am assigning here the RAM. Now this environment is ready. Then I will click on the start button. It will ask for the operating system. So operating system could be in your pen drive or CD-ROM or DVD, or it may be in ISO format. So I have already dumped that ISO format here on the desktop. XP, open. Then we'll click on the start button. So it will take another 2 to 3 minutes. Any question, query from any remote center?
Sir, you can tell us about some useful tools which we can use to teach students, useful softwares. Which are your favorite software?
Okay. Actually, this session is only for the IP addressing, but you have asked also a very good question. There is a one website. Most of the time we download the software from the internet, and those softwares are not genuine. So there is a one website from where you can get 3 lakh of softwares available under open source, sf.net. Every for Windows environment, sf.net.
SourceForge, SF.
Exactly, yeah, SourceForge. This is another name for the website, sf.net. You can contribute also. You can see the source code. You can get the download the softwares. 3 lakh softwares are available. Any other question, query related to this IP version?
सर फॉर एग्जांपल गूगल का एक सर्वर है, उसके ऊपर ज्यादा लोड नहीं पड़े, इसलिए वो राउंड रॉबिन फैशन में आईपी बदलता रहेगा. उसी के लिए आप कह रहे थे कि मल्टीपल आईपी एड्रेसेस कैन बी यूज्ड विद द सेम कार्ड. व्हाट इज द रीजन वी विल लाइक टू यूज मल्टीपल आईपी एड्रेसेस फॉर द सेम कंप्यूटर?
Let's say right now I'm running here one video conferencing with you people, and I want similarly to show you web server, FTP server, DHCP server, or some other applications. So for those I required multiple IPs. Let's say on this machine I want to show you 3-4 websites I want to host on the same machine. So each website has a unique IP address. So how can I host multiple websites on this machine? So I definitely required 4 to 5 IPs. So in that scenario, I can configure the IPs. And what you have asked, that is for the load balancing. What they are doing right now, Google has more than 4.5 lakh servers around the globe. And whenever there is load on one particular machine, automatically it do then the round robin fashion, first come first services. There are 4, 5, 6 different kind of algorithms are there. Based on that, it do the load balancing on different physical machine. But if you want to host on the same singular machine, right now I am using this laptop. I want to show you 4, 5 website hosting on the multiple website hosting on the same machine. So how to configure those multiple IPs on the same machine? And what they are using distributed machines with different IPs. So when you do ping with the google.com or similar websites, you will find different IPs at the different time. And here we are going to configure the static IPs, 4, 5 different static IPs on the same machine. You will see just now installation is about to complete in just 1 or 2 minutes. I will show you how
तो
to
सर
have.
गूगल की जो डिफरेंट आईपी एड्रेसेस है लोड शेयरिंग के लिए, वो तो डीएनएस लेवल पे हो रहे हैं. डीएनएस राउंड रॉबिन फैशन में अलग अलग गूगल के सर्वर का आईपी एड्रेस देता है ताकि एक ही सर्वर पे लोड नहीं हो. और आप जो समझा रहे हैं वो इसलिए है कि एक ही सर्वर पे अगर मल्टीपल वेबसाइट्स होस्ट करनी हो तो मल्टीपल आईपी एड्रेसेस चाहिएंगे.
Exactly, and without having additional LAN card.
यस सर.
Even without DNS, you can have the load balancing. There are different mechanisms or methods are there. Clustering method is there. Then some more methods are there through which we can have the load balancing.
अच्छा सर, एक और क्वेश्चन है. मैक एड्रेस और आईपी एड्रेस को एआरपी टेबल मैप करती है, तो फिर एआरपी पे क्या असर पड़ेगा? मतलब एक ही मैक एड्रेस के लिए मल्टीपल आईपी एड्रेस की एंट्रीज एआरपी में होगी तो फिर एआरपी पॉइजनिंग करना और आसान हो जाएगा.
If you see, ARP poisoning will be only possible when we have the overflushing or overloading of the IP addresses. And when we have the MAC address and IP address combination, both of these, then when we have multiple IPs, so let's say I have IP 1, 2, 3, 4. MAC address is same. MAC is, let's say, MAC 1. So the combination is MAC 1, 1, MAC 1, 2, MAC 1, 3, MAC 1, 4. So all will be unique combination in the ARP entry. I will show you that also now. So there is a one command ARP -A through which you can see the ARP's entries. ये थोड़ा सा मुझे हेल्प करना है इसकी की में ना, क्या नंबर है 72HJ नहीं होगा वो, क्योंकि वो वर्चुअलाइजेशन के अंदर है, वो एक खुद ही ले लेगा. 8YR4V. Two XT62.
सर मीनवाइल ये इंस्टॉल हो रहा है, तब तक और क्वेश्चंस पूछ सकते हैं.
Yeah, you can ask.
ओके सर, ऑरेकल का जो वर्चुअल बॉक्स यूज कर रहे हैं, इसमें एक बार ही आपको इंस्टॉल करना पड़ेगा, मतलब बाद में तो इंस्टॉल हुई हुई इमेज रहेगी.
Yeah, exactly.
ओके सर, मतलब आप अपने लैपटॉप पे काम नहीं कर रहे हैं और आप इंस्टीट्यूट वाले पे कर रहे हैं जिसपे पहले से ये इंस्टॉल नहीं किया हुआ था।
Yes.
Sir, I have used VMware from VMware का virtual machine आता है, that I have used.
Yeah, VMware is a paid one, whereas this is a free and
They have academic version also, and one of my students work with VMware and he has done some patents with VMware also.
okay, congratulations.
Thank you, sir.
So, okay, let me finish the presentation. It will take another 1 or 2 minutes, and this presentation will be available to all of you.
Hello, sir. Hello.
I can hear you.
Sir, suppose we are using this VirtualBox and we have installed some operating system. But the
Yes.
problem arises is if we are having some files in that operating system, it is not accessed from other operating system. So what is the provision for that? How to access that file folders from other operating system?
It will act as a independent different machine. So
Yeah. So suppose
say
I want to share some data from one operating system to another operating system. So what is the provision for that?
let's say you want to share the data from one machine to another machine. Normally what you do, Windows sharing,
Yes,
or
yes.
you can deploy FTP server. Similarly, same thing you have to do here. Either Windows sharing you have to do, or deploy some FTP server, and through which you can upload and download your data.
That.
So this will
Hello.
act as a different machine.
Okay, sir, is there any software available using which we can share that data?
Yeah, one FTP server is there. There is one website. Just note down this, through which you can deploy, make any server,
Please.
FTP server in just in 3 minutes. Just note down
Hello,
this.
sir, it is not audible.
Yeah, just note down this website. I'm writing here, FOSS community dot wordpress.com.
Sir, it is not audible. If you can message or write it in your.
Okay, can you see this? I'm typing on the notepad.
Communities blog.
I'm writing here.
Yes, sir.
Is it readable?
Yes, yes, sir.
So I have opened this website, and you see the link on the left side. I
Yes,
request
yes.
kindly mute your mic. Then you will see the one link, free and open source software on
Yes.
the left side. After this, if you want to have full bandwidth, you can download this OpenCD, or these are the alternate. These are around 110 softwares which you require in day-to-day work. So go here in the this FTP server will be here. So under the category of internet, there is one FileZilla.
Okay, FileZilla. Yeah. FileZilla.
And yeah, FileZilla. Through this you can
Yes, yes,
have the
yes.
client also as well as the server. Just install it.
Okay.
You will get the graphical interface, and it will be ready as a FTP server. You can upload, download. With the help of password also you can configure. You can create the accounts. Many things can be done under this. Similarly,
Okay,
there
okay.
is another software, HT-Track. You can download the full website. So now we left with last 5-7 minutes. So let me complete this session.
Okay.
Now this XP is ready. Now I'm going directly to the control panel. I'm going to the networks, and in the networks you will see options, network connections. Once you go to this network connections, open this, go to the properties, go to this TCP/IP. Now I am showing here. So what was the first rule? 000 is reserved for the network. We cannot use for the host. So I'm trying to assign this IP address. So when I write here 0, what it is showing, machine is showing it is not a valid entry. Please specify in between 1 and 223. Now what was the second rule? We cannot use broadcast address. What was the broadcast address? 255. Now I'm trying to assign on this. So what it's showing, it's not a valid entry. What was the rule? Third rule was that we cannot use loopback address 127. So if we try to assign 127, it is showing not a valid address. And if we try to assign, even we cannot use multicast address, and multicast address start from 224. If we see the series, so if I try to assign 224, so again it will not accept by the machine. So let's say now I will show you how to assign multiple IP address. So let's say I have given here 1.1.1. So it belongs to which class? Class A. And what was the subnet mask for class A? So when I press tab, automatically it will come. Now we'll go for the class B. Class B start from 128 onwards. 128, let's say I've given here. So what is the subnet mask here? Automatically it will come here. When I press the tab, 255. What is the for class C? So let's say I've given here. So automatically this will come. Now you go to the advanced settings and you can address n number of IP addresses to the same machine, maybe of different networks also, maybe same or maybe different. Assign this as unlimited. So randomly I have given here some IPs of class A, class B, class C. So I have here assigned 4-5 addresses, and how to check the IP addresses? There is a command IP config. When you click the IP address, you can see all the address 200, 100, 2 series, 1 series. In this way, we can have multiple IP address to the same machine. So I left with another last 2 minutes. So any question, query so far?
Yes sir, there are some questions. आपने ये XP में ही क्यों बताया? क्या नया Windows ये allow नहीं करता है?
It allows. Definitely it allow. I have this distribution, that's why I have used this XP. If I could have Windows 10 or Windows 2012 with me, I could use that. No, there is no problem, because for TCP/IP setting in all the machines are same. Even right now I'm using Windows XP and Windows 10. If you see here Windows 10, again if you go to the control panel,
सर नहीं समझ में आया, आपने विंडोज 10 यूज क्यों नहीं किया सर?
now I am using Windows 10. Now see here, I'm using Windows 10 right now. I open
ओके, एक्सपी सिर्फ एग्जांपल के लिए बताया था आपने.
no, example के लिए I have used the Windows XP, and for your query now I'm using Windows 10.
ओके
Right
सर,
now-
ओके, गॉट यू
Right
सर.
now I am running two operating system, Windows XP and Windows 10. So you can see here. So I open the view network status, change adapter settings, then go to the Ethernet, go to the properties, and go to the TCP/IP model 4, and same thing you will find here. Again go to the advanced and do the same thing. No difference. So that means you might be using any operating system, maybe Windows XP, Windows 7, Windows 8, Windows 10 or Windows 2012. You will find the same setting in all the operating systems. So it doesn't make any difference. Got it? Any other question?
sir.
Yeah.
यस सर, देयर आर फ्यू मोर क्वेश्चंस. सर, आप मेरे को थोड़ा रिजर्व्ड आईपी एड्रेसेस के बारे में और इलेबोरेट करेंगे? मतलब मल्टीपल रिजर्व्ड आईपी एड्रेसेस एंड देयर टिपिकल यूजेस.
See, these reserved IPs, like for private IP addresses, 10 series, 172 series, and 192 series, they cannot route their data over the internet, never, because these policies have been deployed on the router end. So whenever we have to route data on the internet, we have to depend on the NAT or proxy server. So in the proxy server, we don't have this private IP. There we have public IP, which we got from the internet service provider, and there we do the either netting or we do the proxy, and then only your data can go to the outside world. So this is the one reserved for the private IPs. And as you know, IP addresses are unique in the world. So I am using 192 series. You can also use a 192 same series, no issue, because you are using a private IP address. But you cannot use the same global IP which I am using at the same time. Second private address like 000, that is reserved for the routing purposes and for the network purposes. As I give you the example, if you want to block certain websites for students only and not to the teachers, then through this network address we can control all those machines. Third, sometimes we want to deploy certain application developed in Cold Fusion, PHP, Python, .NET, ASP, etc., etc. Now I want to deploy, I want to test that. So, and I have a standalone machine. So how can I do that testing? So and loopback address is reserved for that. That is 127.0.0.1 series. And these are the further you find in the RFC, request for comment. So these are the standards. So these are the reserved IP 0 series. Broadcast is reserved for the broadcasting, and that is being used by the certain protocols like DHCP server, or in case of ARP. Okay, there was one question, ARP. To see the ARP entry, we have the command ARP -A. So when you run this, now it's showing no IP. So when I say ping some IP, let's say I've given here 200.1.1.1. So when I ping with certain IP, so there is a combination of MAC address with the IP table. So again, if you say ARP -A or ARP, or there is a ARP table, it will show. So when we have the communication among this, now I will show here ARP -A. So you can see there is a, this is the ARP table. So there are two protocols, ARP and RARP. So through ARP with the help of ARP, what it do, it translate the IP to the MAC address. Sometimes we want to do vice versa from MAC address to IP, so there we use RARP. So these are the standards and certain protocols. Any other question related to IP address? Find out we can have multiple IP address on the same machine without having additional LAN cards. We can have kind of classes are there, certain rules we have seen. So okay, one question is coming from Nadu, yeah.
Hello. Hello.
Yes, can hear you.
Yeah, sir. I am having a query. Sir, can you please show me the ARP entries of your host computer?
Simple by ARP minus A command you can see.
Sir, the host computer, the Linux system on which you have shown me the example of ARP.
Right now I don't have Linux right now. I have only two operating system, XP and Windows 10.
Okay,
So
sir. I think that was Windows 10 on
yeah,
which you have shown me the ARP entries.
exactly. Windows 10. This is a Windows 10. I am right
Yeah,
now using two operating system, Windows 10 and
yeah,
Windows
sir.
XP.
I want to know how come there is there are few entries of range 224 and 239.
Okay, because right now we are using these cameras and these multicast addresses are being used by routing protocols,
Okay.
certain video conferencing devices,
Okay,
and
sir.
yeah, and certain special devices. And I have also shown you. Okay, I got one green signal now. I have to finish, but still I will take. I request to take another 2 minutes. Uh, so in routing protocols, special devices, in video conferencing devices, we have to use this multicast address. And already we have seen practically also we cannot assign this class D IP address to the host machine.
Yeah, sir. That why I asked.
सर ये बहुत अच्छा और बहुत इंफॉर्मेटिव क्वेश्चन था ये 224 और 239 वाला. I have few more questions related to MAC address and port address.
Okay. Yeah, you can ask now.
सर ऐसी कोई वेबसाइट है क्या जो गुमे हुए लैपटॉप को मैक एड्रेस से ढूंढ सकती है?
क्या कोई ऐसी वेबसाइट है जो
चोरी हुए हुए लैपटॉप को मैक एड्रेस से ढूंढ सकती है?
Okay. Nowadays we hear that MAC address is unique in the world, but no, MAC address is not unique in the world. We can do
ये
the
सर
duplicate,
फोर्जिंग हो सकती है.
we can do the forging or duplicacy, also known as MAC changer softwares are there, or in Linux there are certain commands we can have. Yeah, I have seen one of the website, but I'm not sure about the accuracy of their results. So on that, even your not only your laptops but also for your mobiles, you have the MAC addresses. In addition to IEMI number, there is also one unique MAC addresses. So there are certain websites and even there are certain open source softwares are available. You have to pre-install on your machines and then you can locate those things. Such kind of applications are available.
Sir,
So
another
next
question
yeah,
is related to port address.
okay.
सर मैं क्लाइंट सर्वर एप्लीकेशन बनाता हूँ एंड मैं एक सर्वर बनाता हूँ, एक क्लाइंट बनाता हूँ. क्लाइंट उस सर्वर से कनेक्ट होता है, उससे आईपी एड्रेस पता है और पोर्ट नंबर पता है. उसके बाद में मैं एक और क्लाइंट चलाता हूँ जो कि सेम सर्वर के उसी पोर्ट पे कम्युनिकेट करना चाहता है, तो मुझे एरर मिलती है पोर्ट नंबर ऑलरेडी इन यूज. ठीक है ना सर?
ओके.
अब क्वेश्चन ये है कि पर एक्चुअली क्या होता है कि जो एक्चुअल वेब सर्वर्स हैं जो थ्रेडिंग यूज करते हैं इंटरनली, तो एक ही पोर्ट पे दो अलग अलग क्लाइंट कैसे कनेक्ट होते हैं, वो इंटरनली चेंज कैसे करता है?
Okay, if you see the real-time scenario of Google, Facebook, all are using the same port, and at the same time we have concurrent thousands of connections are there. So there is
बोलूं सर, मैं कह रहा हूँ कि एक ही सर्वर है, गूगल का एक ही सर्वर है, एक पर्टिकुलर सर्वर है जिसका फिक्स्ड आईपी है, तो दुनिया के करोड़ों कंप्यूटर में से मैंने एक कंप्यूटर को आईपी एड्रेस से पहचान लिया, उसके अंदर 65,000 पोर्ट्स में से मैं एक पर्टिकुलर पोर्ट पे कनेक्ट हो गया, तो वो पोर्ट बिजी हो गया.
right,
जबकि दूसरा क्लाइंट भी उसी पोर्ट से कनेक्ट हो सकता है,
right.
तो इंटरनली वो पोर्ट नंबर चेंज कर देता है क्या वंस इट्स कनेक्टेड?
There is one command I can show you right now, and this is called socket. Socket is a combination of your IP address and the port number. So
Yes sir, yes sir.
when you connect to the remote server, there is there are two sockets are there: client socket and server socket. So server socket, let's say server socket is 1.1.1.:80, like in case of this thing, and client socket may be your IP address colon something. So there is a one command you can note down also: netstat, NETSTAT. Are you able to see this command, NETSTAT, or shall I write down on the notepad?
I can see sir, I have used netstat.
Yeah. So just now, if I open Google, Yahoo, you will find netstat minus NATU or A. It will show. Can you see these? So it's showing my. These are the my local addresses. My
Yes sir.
172.16.22.14. You can see at the same time so many concurrent connections are working in the behind. And if I open new website, it will open. So you can see these are the sockets. So when you are connecting to the HTTPS as a 443 port, and it's showing established. Similarly, on the Google or Facebook or any other website, or redhat.com, or maybe wordpress.com, or maybe another educational website, AICT website, this port will be same, foreign address will be same, but your client socket will be on different machines, or on the same machine will be different. Like IP address is same, but it's showing 51.228, 51432 automatically.
सर ये तो समझ में आ गया, लेकिन सर्वर साइड पे तो जैसे पोर्ट 80 यूज हो रहा है HTTP के लिए, पोर्ट 80 पे मैं कनेक्ट हो गया तो कोई दूसरा पोर्ट 80 पे कैसे कनेक्ट हो सकता है?
Here also you
क्या
can
वो इंटरनली कनेक्ट होते ही पोर्ट नंबर इंटरनली चेंज कर देता है?
Here also, yeah, dynamic ports. Those are known as dynamic ports. Here also you will see in foreign address the IP address and the 443 same. If you see here, netstat minus A on line number 17,
Yes.
18, 19, these are all same. So
तो मैं
similarly, in case of
डायनामिक पोर्ट चेंज, अगर मैं इंटरनेट पे डायनामिक पोर्ट टाइप करूं तो मेरे को ये पढ़ने को मिल जाएगा?
there are three categories of ports: dynamic ports, registered ports, and one more is there, stat 0 to 1024. Those are for standard ports, and 1024 to 49,000 something is there. And if you are using Linux, just open cat etc services. There is a file cat etc services. No need to depend on internet or any Google. You will find all the information. I'm writing here the command cat, or you can use gedit. Open the file, and the file name is, or VI editor etc services. All the information you will find here, all the ports, and even you can change the port, standard port, or customize the port also.
यस सर, फर्स्ट 1024 तो नॉन प्रोटोकॉल्स के लिए रिजर्व्ड है, एक्सपेरिमेंट्स के लिए उससे ऊपर के लेते हैं। रिजल्ट समझ गया, डायनामिक में सर्च कर लूंगा सर।
हाँ। So any other question query from any other remote centers? Somehow we were not able to complete this session, as I showed you on the first slide, a different IP number 1, 2, 3, 4, and the reply was that only number 4 was the IP address, whereas all the three, number 1, number 2, number 3 were the IP addresses. They are the basically now my time schedule has been now elapsed, but those are the different IP forms in the form of decimal, octal, hexadecimal, D-word format, and hybrid forms. So try to explore, or maybe in some other session we'll try to explore those IP addresses again someday. So any other question queries? Still, if you have any question query, or you can email me also, amit@NITRCHD.in. Thanks.
Thank you, sir.
Now, security. So again, you will find all these concepts there. Thank you. There is one request from the coordinator. Now it's tea break for next 10 minutes.
Thank you, sir.
Hello. Hello, sir. This is SES University from Tamil Nadu. Hello, sir. Can you hear me? Hello, sir. Sir, திரும்பவும் where stand it? What's it? Hello. Hello, sir. This is SES University from Tamil Nadu. Can you hear me? Sir, we are not.
Hello, sir.
Sir, we are not getting your voice.
Tamil Nadu. People
Sir,
from.
we are not getting your voice, sir.
Am I audible right now?
Yes, sir. Now it's okay, sir.
Okay, thank you.
Okay, thanks.
Pandyan sir. तमिलनाडु में करना वही 6 दिनों में Pandyan sir, how are you?
Fine, Shahrukh. How about you?
I'm good, sir. Why are you sitting at the back?
Yeah.
Why are you sitting at the back?
Sorry?
Why were you sitting at the back?
Shahrukh, your audio is not clear. I think it's getting some break or delay.
But your voice is coming perfectly clear to us.
Is it clear or no? We can't get your voice.
Is it perfectly coming to us?
Sorry?
Is my voice clear to you?
No, it's getting some breaks in between.
मैं वाईफाई से ही कनेक्टेड हूँ मैं बंद नहीं कर सकता मुझे दिखाना होगा कुछ
Sharon?
அவரு ஏன் அங்க உட்காந்துருக்கீங்க அப்படின்னு கேட்டாரு. சரி உட்காந்து தெரிஞ்ச அவருக்கு அதான் கேட்டாரு. ஒரே சிட்டிங் பேக்.
Sir, you are not audible. TTC Jodhpur.
So am I audible right now? Am I audible?
Yes, sir.
Okay, so we are about to start. There's some network issue at our end.
But we cannot see the slides.
I know that you won't be able to see the slides because there's some network issue. Just please bear for like 5 or 10 minutes max.
No problem, sir.
Okay, let's do one thing. Let me explain each and everything to all the remote centers, right? So let me try to explain the things to you. Till the time we are already trying to get our PC connected to the internet, especially my PC because issue is with the Wi-Fi here. So the security issues in WLAN. But before, let me go ahead and do some shameful introduction of mine. My name is Saurabh Kaushal. I'm working here as a technical administrator in the Computer Science and Engineering Department of NITTT Chandigarh. I'm actively involved in the training of the police officials, BSF officials, and the Central Forensic Laboratory Chandigarh people. My area of interest is perimeter defense, cyber security, forensics, and right now I'm working with the IoT. So let's get started. The objectives for today's particular sessions are to understanding the WLAN terminologies, overview of WLAN frequencies and packets. Believe me that this will be just an overview. Looking at the various packets exchanged during an access point and wireless client connection, that how a particular a mobile phone or a laptop or tablet or a capsule, right, goes ahead and connect to your access point. What is beacon flood, de-authentication attack, keeping our fingers crossed. Let's wait for our internet to work. Hotspot based attacks. I think I will be only able to cover up till the hotspot based attack today. You can also go ahead and have a look at the cracking of WEP. Getting a malicious of the SSL. HTTPS. So what we'll be doing is, onto the wireless network, we will force a particular user to go ahead and use HTTP instead of using the HTTPS, so that we can see the entire communication into the clear text form. So let's get started. And let's make this session as interactive as possible, right? Don't make me feel like a politician that no one is listening at the remote centers, right? I'm just coming and giving my speech and going back. So let's make this session as interactive as possible, because our internet is, internet is not working right now. Understanding WLAN terminologies. STA. What do we mean by a STA? A station or a wireless client. Now, what do I mean by a wireless client? Let's say your mobile phones, your laptops, your tablets, right? These all are the STAs, or your stations, right? Or your workstation, you call it as or in the normal terminology, a wireless client. Discussions already. So that is a wireless client. Let's say, how many of you people are actually carrying an Android phone in their pockets? I think every one of us is right now carrying an Android or an iOS or a basic phone in our pockets, right? But nowadays phones are, they are more the smarter phones, right? Smartphones as we call them. Earlier we used to have the normal Nokia ke chote wale phones. At that time you were having a small phones provided by Nokia at that time, right? And these are the normal phones. Only what you were able to do was, you can go ahead and just make the phone calls and receive the phone calls, and the text messages were available. But nowadays, maximum of your phones are your smartphones. So smartphones give you the ability to connect with your wireless, right? But I will try to demonstrate, right, what consequences you might have to bear, because once you are in the you are connected to a wireless network. The next terminology is BSS. First is STA, which is your station or a wireless client. The next one is BSS, basic service set. Basic service set. Why I'm explaining it? I'm doing kind of a spoon feeding because I know the presentation is not visible to the remote centers. So the participants here at NIAAA Chandigarh, please don't get bored that I am only reading the presentations, right? So BSS stands for your basic service set, is a set of wireless clients nodes communicating with each other. Is a set of wireless client nodes communicating with each other. Let's say in this particular RF vicinity, we are having many wireless connections, right? Everyone of us is carrying an Android phone in our pocket, right? And we are trying to communicate with each other. This is basically called as a BSS, basic service set. Now there are two types of basic service sets. One is your infrastructure BSS and another one is your independent BSS. BSS are of two types, infrastructure and independent. I will be discussing about the security issues, but before we dig deeper into all these things, I just want to give the overview of what are the basic terminologies if we are talking about the wireless networks, right? Infrastructure BSS is those which is a combination of access point and your clients. No, I don't know how many of you will be able to see this particular access point. Is it visible at the remote centers? I am having this, a D-Link
Yes,
access
sir.
point. It's in a pretty miserable condition right now. So I'm having this access point. This access point, along with the stations or your wireless clients, forms your infrastructure BSS. Let's say I have an Android phone in my pocket as well, right? I have this Android phone. Once this Android phone gets connected with this access point, and let's say the participants of NIAAA tries to connect their Android phones, their laptops with this particular access point, this scenario will be called as a infrastructure BSS. In infrastructure BSS, we have your access points and we have your wireless clients. So the combination of these two, APs and clients, is called as infrastructure BSS. Going ahead, independent BSS. Feels pretty awkward right now because nothing is working. Independent BSS. In independent BSS, there are the wireless clients alone, right? And that type of network is also called as your ad hoc network. Independent BSS is only, having the combination of your Android phones, Android, laptops, tablets, capsules, whatever you are using nowadays. Seems
We can see your screen, sir. Your desktop is visible.
So thank you. So I hope the problem is rectified now, that my presentation is visible to you, right? So till now we have only discussed about your STA. STA is your wireless clients. BSS, basic service set, which is a wireless clients or nodes communicating to each other. In your BSS, we are having two type of BSS available with us. One is your infrastructure BSS, which is the combination of your AP and your clients, and another is your independent BSS, which is nothing but the wireless clients alone. Let's have a look. Let's go ahead now. So WLAN terminology is continued. ESS, extended service set, is a set of multiple BSSs, all of them connected together using a distributed system. Now, what do we mean by a distributed system, right? We might have a switch, right? Because right now this is an independent network. I want this particular ESS, right? I want it to be a part of an extended service set, right? That I want this isolated network to be the part of the network available at NITRRR. What I'll do is I'll take a cable from this particular D-Link access point and I will put that cable to that particular system, which is nothing but a switch, right? So that I have a huge network, okay? BSS ID, basic service set identifier. Basic service set identifier. In case of infrastructure BSS is the one which is having your access point and your clients. In case of infrastructure BSS, this is the MAC address of the access point. The MAC address of this particular access point is called as BSS ID, basic service set identifier. The MAC address of this AP it is known as BSS ID. I hope the terminologies are clear to you so far, right? And in case of independent BSS, what is our independent BSS? Independent BSS is the set of only wireless clients, right? Only your mobile phones, your tablets and stuff. In that case, the BSS ID will be, a randomly generated MAC address. Let's say the client who is coming and forming the ad hoc network, first of all, right? There will be some client who will go into the formation of the ad hoc network. The MAC address of that particular wireless client will be called as BSS ID of that particular independent BSS.
Question.
Yes, sir, please.
Sir, in case of a mobile phone can also be an independent BSS, then IMEI number will work as a MAC address?
Absolutely, that's what I'm saying. In case
MAC
of
address is 48 bits and IMEI is how much long?
I'm not even discussing about the IMEI number, right? IMEI is something different. Where do you have your IMEI number on your laptop, right? You don't have IMEI number of your laptop. I'm only discussing about the MAC address.
Okay, sir. Okay.
So let's not, because I don't have another laptop to show you right now. That's why I'm, showing my mobile phone. Don't get confused with the MAC address and the IMEI number. The IMEI number has nothing to do with this security issues in your WLAN or in your WLAN. Sorry.
My question was, if the first client is the mobile phone, then
right.
What will happen?
If the first, let's say, if your mobile phone is going into the ad hoc mode, the MAC address of this mobile phone will be the BSS ID.
Sir, I was not aware that mobile numbers have MAC addresses. I was not aware of that. Thank you.
Okay, what if you want to have a look at the MAC address of your mobile phone? What I will suggest you is, if you are having an Android phone, go to settings, go to about phone, and go to the number, right? Hardware information. Hardware information. Oh, just a second.
Okay, sir, got it.
I don't know whether Mr. Firoz Khan will be able to show you or not. Firoz, अगर आप zoom कर सकें इस पे तो there is a Wi-Fi MAC address. और zoom नहीं होगा? Though I should not show my, MAC addresses like this, but still I'm not left with any sort of option.
Okay, sir. Okay, we understood it.
Right, Wi-Fi MAC address
I
is
was
already
not
available.
aware that mobile phones also have MAC address. So now I got the point. I have understood it.
Thank you. And thanks for revealing my MAC address publicly, right? Okay, going ahead, right? Let me show you a small picture, right? So that you might get the clear understanding, right? Of what do I mean by ESS, what do I mean by the BSS ID and stuff. Can you see this? Is this PPT visible to you? Slide visible to you? Roji? Right.
Yes, sir. Slide is visible.
Can you see this ESS? ESS stands for Extended Service Set, which further has a BSS, which is further having two BSSs. One BSS, just a second, let me turn on this. Can you see my cursor? This is BSS 1, this is BSS second.
Yes, sir.
What do you mean by a BSS? Basic Service Set, which is actually a combination, right? या तो क्या कौन सा BSS हो सकता है आपका infrastructure या
Ad hoc. Independent.
Independent and ad hoc is one and the same thing, right? So if you have a look at it here, this is a infrastructure BSS, which is having an access point here, and two wireless nodes are communicating to this particular access point. And in the similar fashion, we have this access point below the first one, and two clients are again present there. And these are connected using a distributed system, DS, which is nothing but a switch. And this all formation, this all combination is actually called as a ESS. Independent BSS. And if we have a look at the second picture here, which is IBSS, which is independent BSS, it is only having a wireless clients or your STAs, STA1 and STA2, and you can see yourself, right? This is an ad hoc network since there is no access point available, but still these people are communicating to each other. Ad hoc networks. There are so many mechanisms available. We'll discuss it afterwards, right? So I hope this particular picture or diagram is clear to you. WLAN frequency ranges. Believe me, I will be only discussing about, a fraction of all these things, because I don't want to take you into that much amount deeper into the RFCs and stuff. And to be honest, being from the electronic background, I have only read them only for the security purposes. If you want to have a better understanding of these frequency ranges, go ahead. You are free to, go and read the RFCs. WLAN frequency ranges. WLAN can operate in the three different frequency ranges which are available to us: 2.4 gigahertz, 3.6 gigahertz, 4.9 or 5.0 gigahertz. And the 802.11 is the IEEE standard, and this B/G/N, these are the various bands available to us. These are the various bands available to us. I think in India, or if we talk about particularly about NIEEE campus, we are only working on 2.4 gigahertz frequency range. Each of these range is divided into multiple channels. These B, G, N are the multiple channels we are available to us, available channels or bands. Every country has allowed channel users and maximum power levels, right? They can have in their wireless vicinity, right? WLAN packets. There are basically three type of packets available to us in your WLAN. One is management, control, and data. And these packets further have their subtypes, which I don't think, it would be really trivial to discuss all those subtypes because there are tons of subtypes available. Okay, now understanding the functionality, access point functionality. So I would like to know from you people that first of all you let me know that how your mobile phones, or let's say your let's not get confused with the mobile phones, how your wireless clients actually comes to know, or let's say how my laptop actually comes to know that there are multiple access points available into the RF vicinity.
Sir, the wireless thing would transfer the SSID. We will get a set of wireless networks available. We will select one of them. Then it will request for IP address, and maybe using DHCP it will return an IP address on lease basis.
Not going into those things, right? You might have you took the question really seriously. The only question which I'm asking right now to you is that how your access point, or sorry, how your station or your client will come to know that this particular access point is available into the RF vicinity. The only question. Let's not go into the IP address.
If the SSID is transmitted, broadcasted, we will see it in our relay.
Yes, that is broadcasted, but how it is broadcasted? You're 100% right that it is broadcasted, right? That's how your, let's say there are, let's have a look at my PC. How many, I can see this Ramanujan CSC, STC2 is the one which I am carrying. This D-Link access point is having the SSID of your STC2, and this another D-Link access point which is available to us. Now the only question which I am asking is how my laptop is actually coming to know that this particular.
There is a radio electronic device which is listening to a particular 2.4 gigahertz frequency.
Absolutely,
and view the packets going there in promiscuous mode.
Absolutely, it is listening to something, but what is the name of that thing? Because we people are using Wi-Fi like since long time, but still we try to neglect all these small things. That how it's actually a very basic question, right? That how my mobile phone is actually communicating with me, or how my mobile phone, or let's say any wireless client, is actually figuring out that this particular access point is available into this RF vicinity. So this happens with help of your beacon frames. Beacon frames is the keyword. Beacon frames. Yes. The name of the access point is called as service set identifier, or your SSID. Access point continuously sends the broadcast stream. You are 100% right that it is broadcasting something, but I was only curious to know that whether you have actually gone ahead and what is the name of that particular broadcast stream which is available to us. So the name of the broadcast stream is beacon frames. Absolutely, that's how you are able to see, right? This particular access point is actually broadcasting these beacon frames. Absolutely. That's how your mobile phones, your laptops are actually able to see that these are the APs or networks available in this RF vicinity. Everything is, in the air. So the right answer is beacon frames. And this is actually what your APs are doing. They are constantly doing the broadcast or the beacon flood. They are constantly flooding the beacon frames out that, yes, I am present in this particular RF vicinity. Okay. Understanding how an access point communicates with STA. How an access point communicates with your STA. Now, the same question. I don't know who are discussing about the IP address, DHCP and stuff. Now the question is to you, my friend, that how my access point is actually going ahead, and I'm able to connect my Android phone to that particular access point. How is that possible? There is a long process in this thing, right? Very basic thing. I will explain it to you, don't worry. But I want to make this session as interactive as possible. Kind of request packet, perfect. Absolutely. Then what? Of course, if you're sending a request, it will be sending a reply back to you. Okay, let me explain it to you, right? You are on to the right track, but let me explain the terms in the much more and clear and simpler manners to you. Okay. Understanding how an access point communicates with STA. When we turn on the Wi-Fi in our STA, let's say right now, if you go ahead and turn on this particular Wi-Fi in your mobile phone, it will start searching for the available networks, and it will be prompted with the so many networks available, right? STC, 2, Ramanujan, CSC, jitne bhi yahan pe we are having the APs. Everyone is sending the beacon frames. So they have shown their presence to him. But now this particular STA, my wireless client, he wants to connect to a particular network. So what it will do is, it will go ahead and it will send a probe request. This is a very important terminology, probe request. Believe me, even the people from the industry are not aware of how these things are working. A few days back, I was discussing these things with the people who are working for Vodafone, and they were totally blank. They were not having any idea that they were that we are working for the wireless, we are coming with the 2G, 3G, 4G and stuff, but still the basics are missing. Thanks for education. So probe request is sent to the broadcast address, FFFF, right? Access point then sends the probe packet to STC. Access point actually goes ahead and sends a probe response. Why we are STC Jodhpur requested to turn off the mic. Okay, we have already turned your mic off. So probe request. The time I came up, I sent a probe request from my mobile phone. That probe request went to the access point. Let's say our D-Link access point, the name of this particular access point is STC2. The time it will go ahead and it will send a probe request, it will be prompted with the probe response. It sent a request and got a response back. After the probe response, STA sends out an authentication packet. Do you know that whenever you try and connect to a particular access point, it asks for the credentials, it asks for the username and the password, right? So this is the phase where you actually go ahead and enter the username and the password. Probe request, response. Next phase is authentication. Authentication request, and AP sends an authentication response, where you actually go ahead and supply the credentials of the legitimate credentials to the access point. Once authentication is complete, the next phase is of the association. Association is the phase where your AP is actually satisfied by the credentials provided by the STA to the access point. Let's say you might go ahead and enter the wrong credentials. Then the authentication phase will not get completed, right? And it will not get associated with that particular access point whom you're trying to connect to. But if the credentials were legitimate, genuine credentials you have entered, authentication phase will complete and it will go to the association phase. So association happens once your authentication is complete. Then your laptop, mobile phones are actually able to connect to the access point. They're not connected before that, okay? So again, the same, a diagram which I have again captured, taken from the internet. The source is internet. This is my STA client. This is my AP. It sent out a probe request. I will try to show you the probe request and response in the real scenario today, but you have to deal with tons of packet at that time, so please bear with me. Then is your probe response. After the request, we have this probe response. If there was no authentication, like as of now, if I talk about this STC2, can you see? Unsecured, can you see that? I hope that's visible to the remote centers, meaning open authentication. Actually, this is my style of, going ahead for the wireless security issues. I start from the very basics, no authentication, then we apply authentication using web, WPA2 and so on. That's how you can actually, climb up the ladder. But since the time is really less in this particular session, so most of the time I'll be dealing with the open authentication, meaning you don't have to go ahead and supply the username and the password, okay? Going ahead, open authentication, okay, authentication phase is completed, then your authentication response. Now let me ask you a question. What are basically the challenges you might feel while using the WLAN? What challenges you think are available to us? Absolutely. Again, very valid point. Okay, first of all, a question to you: how will you protect something which you cannot really see? Everything is into the air, right? Can you see there's all the communication going on, probe request, probe response? First of all, how will you secure something which you cannot see, which is not visible, right? Or is there some any mechanism, right? You can go ahead and sniff what is actually going on between these wireless devices available to us. Unfortunately, WLAN extends beyond the boundary walls and you cannot really control it. Let's say if this STC2 is particularly, this access point is available in this particular chamber, but it doesn't mean that this STC2 will be available in this particular room only, right? This STC2 will be available outside as well. So that's what I'm trying to say, that it extends the boundary walls and you cannot control that. Makes sense, right? First of all, we cannot see that. Second, it's beyond our control. These all are the challenges, right? And it is difficult to locate a wireless hacker, as he need not to be physically present at your network. Because wireless attacks can be done from miles away. I need not to be physically present at your network. It doesn't really mean that if I want to orchestrate an attack on this particular local area network, I might have to come here, right, and have to be physically present. But if I want to exploit this wireless network, I need not to be physically present here, right? I might sit somewhere else because it is going beyond the boundary walls, and you don't have any sort of security check onto that, and you cannot really control that. So basically, what we can do is how to control that. The question arises how to control that. And as a wireless hacker, I might sit miles away and orchestrate the attack. I hope the things are clear to you. We cannot see it. It's beyond our control. Sniffing attacks can be done from miles away. miles and miles, believe me. I'm coming to that point. Don't worry, I'm coming to it. Right, I have this small little device with me, right? So I will try to explain about each and every device which is available with us here. That's why I'm going slow, right? Okay, so now if we have a look at the objectives portion. So I think what we have done so far is we have successfully understood the WLAN terminologies, overview of WLAN frequencies and packets we have taken, looking at the various packet exchange. Though I will be demonstrating it into the real scenario, but at that time you have to deal with so many packets. Beacon flood attack, deauthentication attack, and the hotspot based attacks. Okay, we will be trying to cover all these three attacks only. Okay, beacon flood, deauthentication, and your hotspot based. So coming back, challenges you have gone through. This particular version of Linux I will be using backtrack today. So enough of talking, let's do it now. But before we start, a small disclaimer to all the remote centers and to the audience who will be having a look at this video at the later stage. The demonstration is for the educational purpose only. The misuse of the information can result in criminal charges brought against the person in question. Presenter will not be held responsible in the event any criminal charges will be brought against any individual misusing the information. The demonstration is meant for providing information on various loopholes in wireless security, and presenter meaning I don't promote words like hacking and cracking. If you again ignore the disclaimer, you will be eligible for a free package to a big hotel like building where you will be getting free food, free milk, free clothes. That will be jail. So I request you please not to go ahead and perform such illegal actions. If you want to do it into a controlled environment, right? Do it into your network where you have the authority. Okay, coming back to the beacon flood attack. So this is the version of, this is backtrack 5 which I will be using today. So is it visible at the remote center? Is the desktop visible to you? Because
yes sir.
Trying to magnify it, control shift.
Change the color of the font and size of the font.
I'm trying to increase the size of font, don't worry. Control shift plus.
Hello, sir.
Yes.
Sir, change the background color of the screen terminal.
It is talking about transparency of the terminal.
Actually, the background is looking black.
Is it visible now?
No, sir.
It's been a long time I'm not in the habit of using this backtrack, so but there are some actually good tools which are actually available into your backtrack but are not available into the recent versions of the Kali or the black box Linux. Is it visible now? Partially readable, or maybe because I have really increased the font.
स्पेलिंग मिस्टेक ଅଛି ସାବରେ
Center is visible now. Centers.
yes sir it is visible
Let's continue now. First command is ifconfig. No need to write it down. Believe me, this is just to check the IP address. I just want to show you a few things here. Press enter. This will actually it will be giving me a hard time to understand because we have actually increased the font and the projector is also connected. So the only interface available to us right now is your ETH0, ETH0 and your loopback 0. There is no wireless card available to you. For that purpose, I will be using this small alpha card which I have with me, and this is having an antenna with a 5 dB of gain. I have a very big antenna, another antenna which is of this much size in in length, and a 9 dB gain it has. So I am connecting this alpha card, which it will actually go ahead and act as a wireless card for my Linux machine, because I have a wireless card in my base system, right? In my base operating system, which is my Windows. But onto this Linux box, I don't have any wireless card available to me. Okay, let me go ahead and plug it in. Give it some time. You might see that my alpha card is coming to life. The yellow light has actually started to blink. So now again, let's go ahead and try to.
Sir, what is Alpha? Is it the name of the internet service provider? Alpha?
No, this is a card, wireless card available to me, available with me. Can you see?
Okay, it is only adapter.
Yes, yes,
okay.
Yes.
Brand name is Alpha.
Absolutely. If we go ahead and press enter, because why I am using this is because I have this backtrack installed onto my virtual machine, right? It's not a, I have not actually gone ahead and installed
yes,
this.
Yes, virtual machine cannot use the actual network interface card which is built in the system.
To provide it with the WLAN card, I'm using this alpha adapter. Okay. Now go ahead and press ifconfig. If you can see that this time I have this WLAN 0 interface available with me. I have this WLAN 0 available with me. But now what I need to do is I need to have a sniffing interface. I need to have a sniffing interface. I have a WLAN card available with me. But are you people aware about that? If let's say if I want to copy all the data of a local area network, and I want to send all the traffic to a particular port, that port is in case of wireless it is called as your promiscuous mode.
Yes, sir.
Or a promiscuous port, right? But in case of your wireless, it is called as a monitoring interface. Promiscuous port is the one, the traffic, it will capture all the traffic which is going through the LAN, whether that particular traffic is actually meant for that promiscuous port or not. It will be getting the copy of each and everything. But in case of your wireless, it is actually called as your monitoring interface. Okay, so I will be using Airmon NG, WLAN 0, sorry, Airmon NG, start WLAN 0. It will actually go ahead and create the monitoring interface which I am talking about. It will receive the copies of entire wireless traffic here, right, which is available here. Because you want to monitor the traffic, right? You want to sniff the traffic, what is actually going into the air, because we cannot see it through the naked eyes. So press enter. Now if you have a look at the wireless interfaces available with us, but this time I'm not using ifconfig, I'm only using iwconfig for your wireless iwconfig. Can you see? I have this WLAN 0 and I have this MON 0. MON 0 is nothing but your monitoring interface. So now let me go ahead and do a beacon flood. Do a beacon flood, right? Beacon streams are the ones with help of which your mobile phones actually comes to know, or your any wireless device will actually come to know that this is a access point. So now let's go ahead, but first of all let me start my Wireshark. Remote centers, you might have to bear with this Wireshark because I don't have the tool with the help of which I can zoom in. Go ahead, click on Mon 0. This is my monitoring interface 0, where I want to capture all the traffic. Okay, I hope you all are aware about the Wireshark. It is basically a network traffic analyzer. Start capturing. You will see tons of traffic. Stop capture. Can you see this 802.11 frames, which are your wireless frames, right? That's what we were actually discussing about, right? And these all are your broadcast frames. Let me go ahead and move to the side. Can you see this SSID is written? Ramanujan, if you want to have a look. This is a probe request packet which we were discussing. Coming from this place, and let me go ahead and show it to you once again. Let me close this, quit without saving. But before we do that, this is the process ID. Don't get confused, it's just, I'm opening the Wireshark, that's it. Let's minimize it first of all. Okay. I will be using this MDK3. MDK3 on your monitoring 0 interface. Small b actually stands for your, or let's have a look at the option, MDK3 hyphen help. Oops. MDK3 mon 0. B stands for the beacon flood. Hyphen
dot
N.
slash, you need to remove dot slash.
It will work with dot slash as well, and without it will also help. Don't, in case of your Kali Linux, it actually works without using dot slash. MDK3 hyphen help. Let's give it a try. Yes, it's. These are the various parameters available with us. Interface, test mode, and the test options, right? So what I'll be doing is MDK3 Mon0, B stands for beacon, flood -n stands for your the SSID. Let's go ahead and let's give it some random name. Let's give it a name as free Wi-Fi. Now have a look at this. What your MDK is doing, it is actually going ahead and with different MAC addresses and on different channels, it is broadcasting, right, that yes, I am available. Now I request the participants at NIEEE Chandigarh to go ahead and open up their mobile phones, and you will be able to see these free Wi-Fi. And for the remote centers, let me go ahead and onto my laptop. Can you see this free Wi-Fi is available now? Remote centers,
Yes,
is free
yes, sir,
Wi-Fi
it is available now. It is available, but my question is why different MAC IDs? Because of different because of different frequency.
It has nothing to do with the different frequencies. It's just at the different channels, it is showing that I am having a different MAC address, so that there will be no conflict. Can you see this? It is different channels are available to us. Channel 8, 2, 14, 10, 7 and stuff like that. And every time it is coming up with a different MAC address, so that there will be no conflict. And the users might feel that this is actually a legitimate access point which is available to us.
Sir, my question is it giving the true MAC IDs here, true MAC addresses for different channels, or these are not true, they are fake?
It is giving a different MAC address for a different channel.
Okay, sir.
So it might actually go ahead and force the user to believe that this is actually a legitimate MAC address or a legitimate access point.
But this is actually legitimate, right?
Absolutely, it is legitimate, right? But how will the user comes to know? If some smart fellow like you is sitting there at the end, you might feel that something is fishy. Absolutely.
Sir, one more question.
Yes, please.
The channel number and the frequency band, different frequency bands and different channel number, one and the same thing?
No. These are different things, right? Onto different frequencies, onto let's say single frequency, let's say 2.4 gigahertz, we can have different number of channels and different number of bands. Bands, my alpha card only supports two sort of bands, which is your B and G band. And these channels are totally different. Don't mix the things. So let me go ahead and stop this. Now your free Wi-Fi will not be available to you. This free Wi-Fi will go. It's gone now. Right now, no, because it's just a beacon flood. I will, we are going slow, right? We will try to, make you people connect. We'll break your legitimate connections and you will force the user to connect with the access point which is available, which is a false access point, which is created by us. But for that, we should have that much amount of time, right? It's already 12:53.
You can take the second session also. You have got 2 sessions with us today.
Your session has already been taken by Amit sir, right? Because we received a request from various remote centers that they want the session on IP addressing or
Sir, actually what we actually want to learn is from an expert like you, and particularly these topics are more important, more relevant to the current day, to the current scenario which we are facing.
I understand your point, but the thing is, they've given me only this much amount of time, as we were receiving the request from so many remote centers that they want to go ahead and have a session on the IP addressing available. Since Mr. Pawan actually started with the firewall session only, so they were a bit curious to know about the IP addressing schemas and what are the various classes and stuff.
Sir, that
One
was
day,
only partially covered today. That also was only partially covered. Only introduction to IP addresses. Only IPv4 and that too very introductory. Because there was lack of time. He wanted to cover a lot of topics. Again, the same thing.
even I want to cover a lot of topics, but because this is a short time, right? I'm having with you people. So let's not waste time into discussions. Let's go ahead and do the deauthentication attack. Now I will request all the participants sitting at NIDDI Chandigarh to actually go ahead and connect with the STC access point available to you onto your mobile phones. For all the remote centers, I don't know how you will be able to connect, though you will not be able to connect, I know that, but let me do one thing. Firozi, if you can zoom in and show what is actually going on. You are connected to STC and you will be able to I have actually made it as a real and a live scenario, and internet is also available to you, especially bought this access point for you people today. Can you see this second one? Oops, the second one is STC2.
More focus is required actually. The text is not readable, but we can see clearly. The mobile phone is in the frame, but we can't read.
Yeah, I request Mr. Firoz to bring the phone in front of the camera. हो गया, आपने इसे हिला दिया.
Sir, previously it was readable, but not now.
Okay. The only thing which I want to show you people is that this second point, right? So second is the STC2, which is available to me, right? So now I want you people to go ahead and connect with this. I'm connected, right? I'm connected with this STC. Let's go ahead. First of all, let's go ahead and try to disconnect everyone. Let me only go ahead and connect with it. Connect with the Ramanujan CSC, because I want to show it to the remote centers as well, right? Because this session is not only for you but for the people sitting at the far end as well. Okay. So right now I'm connected with my Ramanujan CSC. Okay. So guys, let me go ahead and show that to you onto your Wireshark, so that you can get a clear understanding. Let me see that my monitoring mode is still there. Yes, my mon0 is still there. Let me clear this. Close this down. Let's go ahead, go to the capture interfaces. This time we want to capture onto the monitoring mode 0. Start the capture. So much of traffic, tons of traffic, because I'm doing it onto the real network. Believe me, it will be very tough and challenging for me as well. Let's go ahead, go on to the top. Let's see if we can figure out what is this. This is again let's look for a beacon frame. Can you see this is a beacon frame? But I want to be sure that I'm actually connected with my STC to or with some other. Just a second, because because I'm connected with the projector, so it's not able to go to the another end. Let's again wait and have a look at this one. What I'm basically interested is into this. What particular beacon frame it is. Is this beacon frame, flooded by the STC2 or the another RF, access points which are available in this RF vicinity? This is again, can you see? SSID parameter set as Ramanujan CSC, meaning this is not the STC2, and I will actually not want to attack this Ramanujan CSC, because the time I will go ahead and attack this Ramanujan CSC, first of all, what will happen is my connection from the internet will get broken, because I am connected with Ramanujan CSC. The time I will perform the deauthentication attack, what will happen is my connection will get broken. So I don't really want that, okay? So that's why I'm looking only for the beacon frames. Again, Ramanujan CSC. Ramanujan CSC is everywhere. I can actually search, but it actually shows. Okay, let's do one thing. I have another idea. Let's close this first of all. Quit without saving. Capture. Interface. 10. Start. Let's start it, right? Tons of packet. And this is, believe me, I'm doing this first time onto the real network like this, where I have so many packets to deal with. Let me go ahead here and let me connect with my STC. From my mobile phone, I'm connecting with this STC which is available to me. Ramanujan CSC, no internet क्यों आ रहा है फिरोज? Connect. It is connected. Now what I'm interested in, let's have a look. Let me stop this capture. wlan.addr. Okay, I know that this is the MAC address of my machine. Selected. Let me go ahead and type in as it is. 5C colon 51 colon 88 7D and this. Apply. First packet which I discussed with you was probe request. Can you see this probe request?
Yes, sir.
First packet was probe request, right? So I'm able to see that my mobile phone actually went ahead and sent a probe request to the various access points, right? Or to a single access point it actually wanted to connect to. Then we got the response back. From what particular place I got the response? From this particular source. Now I want to actually go ahead and see that what particular MAC address is this, right? So for that I will be using aerodump ng onto a monitoring mode. It is actually going ahead and showing me all the, let me stop it. It has actually gone ahead and shown me all the BSS IDs, what the power is, what the beacon, how it is sending the beacon. This is the data, how amount of data it is sending. What are the channels available, what encryption they are using, whether you are using WPA2 or whether that's an open encryption, right? Control Shift minus. Let me again run this. Can you see this STC? Because I have actually zoomed in, so you might not be able to completely view STC2. So it is only showing STC as of here right now, and the MAC address is this. Or what we learned from the slides was that MAC address is nothing but the BSS ID. Okay, cool enough. Probe response. So many responses. Acknowledgement, authentication. We actually connected with whom? We connected with this particular fellow out here, EDF8. Initially I was connected with this Ramanujan block. I disconnected from the Ramanujan CSC, and I then again connected with the STC2. And in the meantime, what my Wireshark was doing, it was actually waiting for and capturing all the traffic. So it has actually gone ahead and captured even a single bit of the traffic. Let's go ahead. The whole idea is to tell you that what we learned from the slides: authentication request, authentication response, then probe request, probe response, authentication request, response, then association, right? Then we received the authentication. This is a subtype. This is again a management frame, right? I discussed that how many frames are available: management, control, and data frames. This is the part of your management. Then it got associated. Can you see? And it was actually connected to whom? To Ramanujan underscore CSC. Then again I disconnected and again started to connect with all the possible APs. So this is how your communication actually goes. So now this time what I want to do is I want you people to go ahead and connect with your STC2. All the participants sitting at NITTT, I request you to go ahead and connect with your STC2. Are you connected? I hope I was able to do the justice in the small time that, right, though I was not able to cover much of the things, but still you might have got the some basic idea how your mobile phones are getting associated, right? So now this time what I will be using Air Replay NG. Air Replay NG hyphen bauth 0 hyphen a. If let's say if I want to attack particular this, I think I closed that. If in case I want to let me run arrow dump ng once again, otherwise my connection will be lost. Arrow dump ng onto the monitoring mode mon 0. Where's my STC? Here's my STC. Let me copy this, right? Let me control shift tab. Okay. A replay ng hyphen bauth 0 hyphen a is the BSS ID where you want to go and attack. On this particular BSS ID, I want all the legitimate connections to go and break. You guys remember the scenario, right? Probe request, response, authentication request and response. The time I will, and then you get associated with. The time I will send the deauthentication request to you, the authentication packet will get comes into the picture and it will break the authentication. And you will never be never will be able to go ahead and associate with the access point availability. You might feel, right, internet kharab hai ji. My internet is not working. Seems that there is some issue with my internet connection. Actually, it is blocked by the wireless attacker. Absolutely, I will de-authenticate. I will be working as a attacker right now onto a real network. Believe me, I need to take the permissions from my HODs, right? Am I able to actually go ahead and perform such activities onto the live network? They have given me the permission. They have said if anything wrong happen, you will be the responsible person for that. Okay, just coming back because our remote centers are waiting. It's already 1:10 in my watch. You people might be hungry. IG on to ignore initialization vectors. This is IG stands for ignoring some factors onto the mon 0. Okay, the thing is that mon 0 is right now onto channel number 9 and the access point actually uses channel number 10. So now let me go ahead and go to the channel IW config WLAN 0 channel 9 IW config mon 0 channel 9. So now my access point and my this wireless card, they are onto the or let's say my monitoring interface, they are onto the same channel. Okay, so now let me go ahead and run the same attack once again. I just changed it, right? Absolutely, that's what I'm doing, right? Let me have a look at it here. This is on channel number 10. Okay, no, actually we from 9 we were only at the channel number 9. WLAN 0 channel 10 IW config mon 0 channel 10. Now I should be able to go ahead and run the same attack. Okay, have a look at your mobile phones. Your connection to STC will be dropped, STC2. So participants at remote center, I know that you won't be able to see that what is actually happening right now, but still let me go ahead and try to show you the thing. STC2 is already saved here. Go ahead and connect with the Raman right now. If I try to connect with this STC2, we try to connect it, it will never go to connect, right? It will be never connected. The only reason is there is an attack, or what we have done is we have launched a de-authentication attack. Are you able to connect? Have a look now. Will you be able to connect now? Try to connect with your. Can you see this STC2 is getting connected? Firozji, if you can, zoom in here. Right now, my STC2 is connected. Now it is connected, right? But let me run the attack once again. Focus more if you can. Guys, can you see at the remote center? Have a look at this first one. This is STC2. It is connected right now. Can you read this? Connected. Rose is trying to put every possible effort. I think we should, compliment him. Now it's clear, right? At the remote centers as well. Okay, zoom in, zoom in, zoom in. Don't zoom out. Don't be in so much hurry. Now what I'm doing is I will be going ahead and will be orchestrating the same attack. And the time I will press enter, what will happen is the connection to the STC will get break, and my phone will be connected to Ramanujan CSC because that is already a saved network. Okay. Can you see the connection gone, right? Ramanujan CSC went on the top. Control Z. STC again coming into the picture. It is again connected. The time I run the attack, it is disconnected again, and my Ramanujan CSA is connected right now. So this is just a a small picture that what a attacker can do while sitting at a miles away. Believe me, I can perform the same attack while sitting miles away, right? Believe me, thanks to this small little antenna I have or the wireless adapter. So remote center, so far if you are having any questions you can ask me, because I think the time is already 1:15. I think we should find out.
You can just tell us, if you are not continuing the session, you can tell us the topics of the slides, so at least we can know what we can do on ourselves, and you can suggest some software tools which you prefer and which you were supposed to tell us. Just tell us the name of the software and the title of the slides.
Title of the slides are going ahead and breaking your wireless encryptions. You might be using web, WPA,
HTTP, and you told us that you will make the user believe instead of using HTTP, we will fake HTTP as with HTTP.
Okay, you want to have a look at that as well?
Yes, sir. Or you give us some other pointers from where we can do. You can send us some links.
Not an issue. Let me show that to you as you are requesting, right? Now I'm closing this particular backtrack instance. On to your request, from which college you are talking?
From TTC Jodhpur, MBM Engineering College.
Believe me, other people might really get angry to you, right?
You can view the classroom.
They're already full at your end. Okay, only one is there. Now other people, other centers might feel offended because this is their lunch time, right?
Gyan Pipasu.
Sorry? Absolutely. आपके लैपटॉप से उसको ब्रेक करना पड़ेगा, उसको ब्रेक करना पड़ेगा, टाइम नहीं है ना. Kind of. Absolutely. Okay, let me go ahead and use this one. Will be quick. Ah, damn it. Can't really help, right? Have a look at this. I'm, this is my Windows instance because I need to, demonstrate the things to you. So just bear with me for another 5 or 10 minutes, right? Sorry? So what I'm basically doing is, whenever you go ahead and always go ahead and type www.google.com, gmail.com, facebook.com, that you see that HTTPS is in the picture, right? This is something which I personally feel I should cover in each and every class I take, or every faculty development program I take part in. Reason being because this is something which we all should be aware about. Whenever we go ahead and use www.google.com, facebook.com, what actually happens is, ask me later, bit embarrassing that I'm not using a legitimate copy, but this is actually just to show you people. No, it is actually just to make you people understand that what people are actually doing. So I take the cases from the live scenario. So this is actually because of you I'm doing this. Okay. Control Shift plus plus. So then I'm taking the remote desktop of the Windows machine. (163) is the IP there. So I need not to hop between the two machines. Yes. So the time you go ahead and type your www.google or let's say your facebook.com, ask me later, you need to ask me today only. Dot, let's say your facebook.com. It always comes with the HTTPS, right? Can you see remote centers? It is HTTPS. Now, why this thing is happening? Yes. Why this thing is happening? Reason being because majority of the your what we call them as your web servers are actually running on HTTPS, and by default the request from your machine goes to the server from HTTP. Instead of going from HTTPS, it goes from HTTP, and at that time the server says no, you are coming from HTTP, and it actually prompts him back with a error code of 302 that if you want to make a connection with my server, you need to come with HTTPS. So it will comes with the HTTPS connection, and the connection will be established. But in this particular scenario, what I will be using is I have one victim machine, I have one attacker machine. Sorry, I have one victim machine and I have one web server. In our case, I'm taking the example from Facebook. But what I will be using this time is, let's have a look. Whiteboard mode. Come to live soon. Oops. We're all understand the scenario. This is my user. On this internet somewhere I have this FB server. Right? Whenever it sends a request from HTTP, it will send him a request back. No, with the error code of 302. 302. If you want to make a connection, come through HTTP. But this time, my attacker, a bad user, comes into the picture. What he'll do is he'll spoof. He will now act as the default gateway for this machine. All the traffic will go to him first. As this fellow has a condition that every connection this web server will make should be HTTPS. So attacker will make a HTTPS connection with him for this particular fellow out here, and will make a HTTP connection with this. so that user at the end of day is using your HTTP.
How will the attacker introduce himself?
We are coming to the point, don't worry. Okay. For that, this particular attacker should be physically present into the local area network. Should be physically present into the local area network, right? I told you that wireless attacks can be done from miles away, but in case of your wireless, in case of your wired, he has to be physically present, right? So this will make HTTPS connection with him and HTTP connection with him. But the question arises, my laptop doesn't really have the capability to forward the traffic to the internet, because this is not a router, right? This is not a default gateway, right? This should not be this is actually not the default gateway. Majority of times you point a default gateway towards your router, who is connecting you towards your internet, right? But this time, what we need, as an attacker, what I need to do is I need to turn on the IP forwarding. IP forwarding I need to turn on onto this machine. Then only it will be able to send the request to the FB server on his behalf. Okay, I hope the scenario is clear to you. So coming back, exclusive mode. Let me close this. Oh, I think I should have kept that open. Anyhow, coming back here, ls rm hyphen SSL strip log clear. First of all, I'm turning on the IP forwarding. Don't worry, I will explain the commands to you. It's really that I am really bad at remembering all the commands. That's why I prefer to keep a note of it, right? Because silly things do happen only at the time of presentation. Okay. So what I'm doing is, by default it is 0. I'm turning it on, right? I'm turning the IP forwarding in the on state. Next, I am setting some firewall rule, IP table rule. Copy it, paste it here. This rule says IP tables -t NAT this, any traffic destined for port number 80 should be redirected to port number 8080. Then I will be using this ARP spoof. Let me copy it. Copy. -T stands for the target, right? On what particular machine I'm targeting? I'm targeting this particular machine, which is having the IP address, IP config, having the IP address of 192.168.52.163. I'm targeting this particular machine, okay? 192.168.52.163. -R stands for your default gateway. What particular default gateway? Default gateway of, if you want to have a look at the default gateway, open tab. Command is route-n. The default gateway is 192.168.52.2 for this particular machine. 192.168.52.2. Something's wrong. It should be -I, I believe. Okay, our spoofing is on right now. What I'm doing is open tab. I need to run the SSL strip now for port number 8080. You remember, any traffic which is going towards port 80 should be redirected to 8080. Press enter. Now I need a volunteer who can come and enter his Facebook credentials, facebook.com. This time you will be watching that there is no HTTPS. We have actually went ahead and forced the user to use HTTP instead of using HTTPS. So I need a volunteer from NIEEE Chandigarh who can come and enter their Facebook username and password. It would be better if I type in why to reveal your Facebook username and password publicly. If you want, you can go ahead, right? So we have a ma'am here. She wants to reveal her Facebook username and password publicly.
No, password तो asterisk में है.
करो.
गलत दे दो ना मैडम.
Be careful, be careful. Don't be in a hurry. So, she's actually worried now. Karuna ma'am is worried. So, ma'am, we are not having a look at any of the communication. She seems to be a busy lady, right? So many notifications, so many messages, and some random friend requests. So, ma'am, we haven't seen any sort of communication. We have successfully logged out, right? You can see the thumbs up sign. Let me go ahead and you open tab cat ssl strip.log. Let me have a look at her. Let me open up my favorite editor, which is Nano, not Nono, Nano. SSL strip.log. What happened? Something wrong. Control W. Pass. Was this your password, ma'am? Was this your email and this is your password? Need I say more? So we have successfully revealed the password of Karuna ma'am. So I request you to kindly go ahead and change your password. So I hope on to the request of TTC Jodhpur, that's how you actually go ahead and force the user to use HTTP. That's how you strip off the SSL header. So that's all for this particular session. It's already 1:32 in my watch. So I hope you enjoyed the session and go ahead and have your lunch, and we'll start our next session around 2 or 2:10, right? Because we are already giving the we are already winding up the session very late. So remote centers, I hope I was able to make the justice to your time.
Yes, sir. Thank you.
Thank you very much. I think कुछ worth रहा इसको लेकर आना, right? So remote centers will now connect around to 10. So thank you very much, participants. I hope you had a wonderful session. No, absolutely. Nothing to be known. Nothing to be known. Believe. No IP is needed. Not at all required. Believe me. Absolutely. I'll show it to you if you get some time, coming STC. You are here for any STC. Being conducting in the contact mode. I will cover it. Thing is, not everyone will be interested in security. Right. Security should be, made compulsory. I think the centers are also in right. I'll do it. ये ग्रुप तूने निकाल दिया. I remember I was taking a session there at Indraprasth University, IPM. I broke their Wi-Fi publicly. You must have had that network administrator. They called me for an expert talk there for 2 days. Madam, I had a lot of time. I just went in. Was spreading bytes. NISSC दूसरा भी है NISSC.ac.in सौरभ had created something, but I use this usually. If you want to connect with me on Facebook, Karuna ma'am, Karuna ma'am का भी 15 दिन connect नहीं करेंगे. अभी पहला प्रायोरिटी पे काम कीजिए. Search for Saurabh Kaushal season 4 on Yahoo. You will be able to find it. कोई लंच के लिए भी नहीं जाना चाहता था आपने से आज. वैसे उल्टे गाँव में सबसे Absolutely, you can. That time the internet of my relatives were not working, and I was a little bit offended. And I wanted to use internet desperately. So what I did, I broke into someone's network. Just find the number of users, databases, Facebook users, Yahoo users, and all. वो यही सबसे तो आते हैं. This is the way they are collecting, right? Absolutely. You should not use torrents. Believe me. अभी टाइम नहीं मिला कि मुझे torrents पे डिस्कस करने का because the topic was more onto your wireless. But believe me, torrents are really dangerous. I lost my computer while wireless network. Okay.
अभी तो चल रहा है ना, ब्रेक चल रहा है।
चलो
तो मेल में ओपन करते हैं।
वो लैपटॉप ऐसे पड़े हुए हैं ना।
ये प्राइवेट नेटवर्क
ये तो सेंटर रेडी होकर मेरे को बुला लेना। जरूरत है करूंगा। पेन क्या कौन सा वो लिखने वाला पेन कौन सा है? सही में अच्छा जो है अच्छा जो है सीधा लिखना है ना।
ये बटन
पीछे को करना है लिखते टाइप करना है यार
प्रेस ही नहीं करना है।
अरे उसको नहीं प्रेस करना है। अच्छा 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 नॉर्मल पेन जैसे लिखते रहे बस दैट्स ऑल है ना। जैसे कि स्क्रीन आएगा तो इसमें लिखना हो। वही रखना है ऐसे ना। ये जो नया लिखा है ना ये वाला ना वही वाला ना सो यदि बाहर आ जाते हैं
ये वैसे
कागज ठीक है तो प्रेजेंटेशन जैसा कनेक्ट हो जाता है
जी। Yeah. वो दरअसल ऐसा है कि सर वाले सिस्टम में तो थोड़ा सा इशू था। सर वाला तो ऐसे हो गया। कैसे समझे? फीमेल कैसे यूज करें? Remote centers. Hello. MIT Muradabad.
हाँ फिरोज जी, MIT मुरादाबाद।
Participant, sir, your center attend course.
सर पार्टिसिपेंट्स अभी आएंगे क्योंकि पहला सेशन थोड़ा देर से खत्म हुआ था, तो लंच पे जरा लेट गए हैं।
Okay, sir, number of participants totally.
सर लगभग 55 है।
क्या?
55
65
50 55
55. But sir, during session, yeah, your camera is focused on participant. But at 10, 11,
Pardon?
and attend the course. ये screenshot I have in my PC.
मतलब आपको नंबर ऑफ पार्टिसिपेंट्स कम दिखाई दे रहे हैं?
पार्टिसिपेंट जो पार्टिसिपेंट अटेंड कर रहा है उसको आप सर्टिफिकेट के मना ही कर दीजिए सर्टिफिकेट इश्यूज।
कौन तला पड़ दिला के आपण कोण ना फिर तला ठेले तबसी बाहर ठिया सिक्युरिटी हट को तेरे हम केते संबंध बुले बुले आले तला मला इपडे आले एडमिट पडे आले नाही सही पडे
ओके विकास सर
ओके विकास सर।
किसी जोधपुर
यस सर।
नंबर पहला सेंटर
12 हाँ सर 12।
चंडीगढ़ यूनिवर्सिटी।
हाँ जी सर।
नंबर ऑफ पार्टिसिपेंट यूर सेंटर।
सर 25 to 28 है सर।
25 to 28. But sir, during session, your
Sir,
faculty or your participant talking is work of your computer. Not very interested session. मतलब session तो सुन ही नहीं रहे कोई लोग और अपना अपना काम कर रहे हैं.
नहीं सर नहीं, वो अभी कर रहे हैं क्योंकि अभी उन्होंने देना है डेटा. अभी जैसी सेशन शुरू होगा फिर दोबारा वो
मेरे पास पहले का फोटो पड़ा है. ये आप बोलते तो मैं आपको स्क्रीन कर सकता हूँ.
बीच में हो सकता है सर, क्योंकि आज थोड़ा सा कुछ ज्यादा वो चल रहा है. आज हमने सेशंस इंटरनल्स वगैरह देने हैं तो इसलिए थोड़ा सा लगे हुए हैं सर.
अभी सेशन है एचओडी सर का सेशन है, प्रोफेसर श्री रामाकृष्णा का. प्लीज उन्होंने व्यू देखना है कि क्या हो रहा है, इसलिए आपको मैं सेक्शन दे रहा हूँ.
ठीक है जी, ठीक है
सर. JSS Academic, can you hear us? Noida, JSS Academic. Hello, can you hear us? JSS Academic. Hello, JSS Academic. Turba College, can you hear us? CV Raman Engineering College.
Yes, sir.
Madam, number of participants in your center?
45.
Ma'am, but 45 attend the course?
Yes, everyone has attended, but now they are late because the session was continuing up to more time. So they are gone up to for. They will be coming.
50 participants attend the course, morning session.
In morning section, 25 around, 20 to 25 around.
No, ma'am, 15 participants in your center in the view of camera.
Yes, somewhere some have come then gone because evaluation of the copies are going on. So some could not attend in the first session. They will be coming in the second session, sir.
Okay. Mulana, Mulana. JIT Jodhpur. JIT Jodhpur, can you hear us? TTC Jodhpur. TTC Jodhpur.
Two participants are here and rest are coming.
Number of participants in your center?
12 participants.
12. Okay, ठीक. SESVM University. Total number of participants in your center?
27.
27.
Yes, sir.
At view of 5, 7, 8. In this time is present 8 participants.
Sir, your university lab exam is going on. So that faculty is, they'll come after 3, sir.
So mostly time your participant is gone. Mostly time participant is your center is 5, 7, 9 SE. Mostly time.
No, some faculty are attending lab exams. That's why.
Okay, sir. JIT Jodhpur. Hello. JIT Jodhpur. TTC Jodhpur.
JIT Jodhpur is not here. TTC Jodhpur is available here.
MME Mulana. Hello, I'm Mulana. Center available is school start current class. One, two, three, four, five, six. MME Mulana. MME Mulana. GSS Academy Noida. Can you hear us? Hello. GSS Academy Noida. Can you hear us? Prabha College. Can you hear us? Truba College.
Yes, sir.
Sir, number of participants in your center?
Sir, total number of participant 10.
And?
Total number of participant is 10.
Okay, okay. MMU Mulana?
Ji, sir.
MMU Mulana?
Yes, sir. Total 26.
26, but your view is camera is 1, 2 years. Your camera is not detecting you fine, only fine work. Yes. Many times you are using fine work. Only fine आपका show हो रहा है screen पे. But no number of participants. Please अपना जो कैमरा लगा हुआ है उसको सेट कर लीजिए.
ठीक
कल भी
है.
प्लीज आप लोगों के लिए स्पेशल है ये कि कैमरा अपना ठीक है पार्टिसिपेंट को बुलाइए अदरवाइज आपका सेलेक्ट जो एंटर रिजेक्ट हो जाएगा. आपका लास्ट डे रह गया है प्लीज तो इसलिए बोल दिया कि सेंटर काट दो नो इश्यूज तो सेंटर का इसलिए प्लीज अपना सेंटर्स में पार्टिसिपेंट चाहे 5 पार्टिसिपेंट है नो प्रॉब्लम 40 पार्टिसिपेंट को 5 को ही सर्टिफिकेट मिलेगा तो नो इशू बट सर्टिफिकेट पार्टिसिपेंट है प्रेजेंट होने चाहिए. जेएसएस एकेडमी JSS Academy. Remote center. Your screen shows the PPT. Remote centers. You can see the PPT. Yes or no?
Yes, sir. Yes, sir.
Sir, it's visible. It is visible.
Mic is set. Good afternoon to all participants, those who are at Chandigarh Center. I can see here 3 participants and then all the participants at the remote center also connected from various parts of India. First of all, I would like to tell you something about our department, right? Because my faculty might have not explained to you. And this department is established in 1969, and from that time onwards, it has progressed steadfastly. And we are running a ME program also, Masters in Computer Science and Engineering from 1991, which is AICTE recognized. And then in 2005-06, we have started ME in Computer Science in regular mode as well as modular mode. Modular mode means summer vacation, winter vacation, specifically for teachers, those who are working in the engineering college and polytechnics, so that they can improve their qualifications. Along with that, we also have started a PhD program in computer science engineering and other disciplines also. So all the teachers, right, sitting in Chandigarh, sitting in remote places, right, you can avail this facility of ME modular program as well as PhD program. Apart from that, whatever these ICT based courses, lectures are going on, these videos are straight away recorded onto the YouTube. And then you can also visit our website regularly, right, nitrrc.ac.in. Then you will find a link on the right topmost corner, NCTEL, which is on the similar lines of NPTEL of IITs and IISc. And we have right now around 1150 video lectures are already available under different disciplines. So go to the website, then open NCTEL, then you will find subject-wise, department-wise, discipline-wise, you can see the video lectures. That will be more interesting for you. So that's a brief about the department, and then we request you, right, to propagate to other colleges also about these ICT programs, online programs. And then this time we have made it a little more quality oriented, because we got the feedback in some of the centers that participants are not participating properly in the centers. So we have decided that the centers which are indisciplined, right, will be disconnected without any thinking further. So it is you who have to make this program successful. So if you attend sincerely, we are putting our best efforts possible from our side, and it will be really useful to you. And then we have also got a program that if any of you, right, because all of your teachers, if you feel that you are best in a particular subject, let us say you are very good in C++ programming, you are most welcome to record your lectures coming to Chandigarh, and then we'll pay you a 5,000 rupees honorarium for 1 hour recording, 1.5 hour recording. So you are most welcome for utilizing this facility also, but only thing is you have to prove that you are the best in C++, right? That's a requirement. So that's the department. And then I request remote center participants also come to Chandigarh at least once in a while, right? Don't be always in Kanpur or maybe in Andhra or maybe in Tamil Nadu, but come down to Chandigarh also sometimes so that you can see some of the facilities, some of the features which are going on here. Okay, that's a brief of the department. And let us going back to the lecture, right? This is on issues in mobile ad hoc networking. We will see that how much we can complete in this roughly 1.5 hour time. So as we go with the lecture, right, we start with a brief history, right? It's very important to know history, like whether this ad hoc networking concept, which we are trying to learn today, is exactly that, how old it is and when it has started, right? Who has started it, from where it has started, and then what is the status as on today. Then we'll see a brief introduction to a physical layer, because mostly the centers are participants are from computer science engineering field. That's why I have not touched much upon physical layer issues, but rest of the layers we will be trying to discuss as far as possible. Then we will discuss more detail about MAC layer, then routing and transport layer issues, quality of service issues, security issues. Additional resources are there which will be useful for your further reading. So in this lecture, we'll try to focus on the various issues at various layers without going into much into various algorithm details. So regarding the history, you can see here that the idea has started somewhere in late 1960s. That means if you try to calculate, it is as old as more than 45 years back. This idea has started, and it was sponsored by DARPA, that is US Department of Defense. They have given a project in the name of PRNet, Packet Radio Networks, and then the purpose is for military communications and disaster management. And you will see and appreciate this idea when we were not knowing what is a computer, when we were not knowing that what is a network, and US Department of Defense has started an idea called Packet Radio Network somewhere around 1970s, right? It's more than 45 years old, this idea, and the purpose is for military communications and disaster management. It's very interesting, and the idea is very good, but it could not really come to the shape as they were thinking. One of the biggest issue was the size of the device, right? When you think of late 1960s, around 1970s, and I am sure that, right, many of the participants may not have been born also even, right? Those who are young in age, and the size of the device was very big, right? Very bulky in size. So it was not really possible for the soldiers to carry this device when they are safeguarding the borders. Let us say that India and Pakistan border, many soldiers are there in Leh and Ladakh. And communication device is a second or third option, right? First is they have to survive against the weather environment, and then they should take care of their protection first. Then the communication also comes into play. So the device was bulky, right? Let us say 4 to 5 kilos in weight, which is not possible for a soldier to carry. And as we can see now, right, the mobile phones are coming at a weight of 50 grams, 100 grams, 150 grams, 200 grams, which is very easy to carry. That was a dream, a device which can be of what we are seeing today, but that was not possible in 1970s because advanced VLSI techniques were not available. Hence, this idea did not really take off the way that they thought. Then finally, they were using in the military vehicles. That means device was kept in the military vehicles and they were serving the purpose. And then somewhere around 1980s, still again they revived this idea in the name of survivable packet radio networks. Then we could see the 1980s also, right? Many of us maybe I was in a class of 9 years old, right? By 1980s, I was 9 years old. So forget about computer, forget about networking, forget about these mobile ad hoc networks and all, right? We were going to school, right? 9 years means maybe I was in the 4th standard. And here people are talking about survival packet radio networks, right? And then they are trying to give a device for the soldiers and for disaster management and all these things they are talking about. And we can very well imagine the situation of India also in 1980s, what is the status, right? So hence in 1980s also not much could be done. But somewhere in 1990s, IETF, right, Internet Engineering Task Force, started a group called Mobile Ad Hoc Networking. It is a breakthrough year, 1990s. Countries like US, Japan, they have started this mobile cellular systems, right? Cellular networks they have started. And first generation cellular networks, right? AMPS, for example, in US, Advanced Mobile Phone System. They came up in countries like US and in Japan, a similar system has come. And then mobile phones, you might have seen the older mobile phones like Nokia, right? It was of a cardless phone size with an antenna outside. They were using such type of systems. And then there is a hope that, yes, now we can come up with a technology where a handheld device can be possible. It is possible to create it. And then IETF started this again, mobile ad hoc networking idea in somewhere 1990s. And then around 1995, we could see the IEEE released this 802.11 standard, which is a wireless LAN standard, right? And it started coming in laptops, and then wireless LAN cards started available in the market. And then later on, after 1995, IEEE has come up with many versions of it, like IEEE 802.11b, G, N, right? And so on and so forth. So this gave an idea that, yes, now we can think of creating the original packet radio network, which is basically a device, a handheld device, which can act like a host as well as a router, and which should be possible to create a true mobile ad hoc network. But there are many issues and challenges. Some of them have been addressed seriously, but still some of them are at research stage. That we will see what are those things. So what is an ad hoc network? It is a simple definition is network of wireless nodes. Nodes may be static, nodes may be mobile, depending on the requirement. One of the important feature is no pre-existing infrastructure is required to create this ad hoc network. And that means if you want to create a cellular network, you need to have a lot of infrastructure is to be in place. Suppose you want to compete with Airtel, you want to compete with BSNL, you want to compete with Vodafone, right? You have a lot of money that you want to become a cellular operator in this country. First thing is you need to have a lot of money. Other thing is you need to purchase the license, because cellular network license band is you need to purchase it. It has to be auctioned and you need to purchase it. It's not free. It is not a license payment, it is a license band. Then after that, a lot of infrastructure has to be in place to make this network really a possibility. But whereas here an ad hoc network, which is with a different purpose, it doesn't require any pre-existing infrastructure like base stations, fixed links, routers, centralized servers, and so on and so forth. So you can create this network quickly, and at the same time, you can also remove it when you don't require it. Then the question comes that, sir, when a node is away, right, single hop away, then how is it possible? Because there is no router is there, who will do the job of routing? So here the concept gets deviated. Like what all devices that we are seeing right now, they are acting like a host only, right? But the devices that we are planning to have for ad hoc networking purposes, it has to work like a host, just like it is working now, and it has to work like a router also, right? That means every node which is going to be participative in this ad hoc networking has to be a host as well as a router. That means data can be relayed by intermediate nodes if the source and destination is more than 1 hop away. And then all these nodes can be mobile also. That means whatever route that you establish, it may be existing for some time depending on the mobility of the nodes, and the route will be broken and route has to be created dynamically. So whatever we see in the internet infrastructure today, the router is fixed, right? You go to any institution, any organization, right? You have a server room or you have a data center where your router is always fixed. It is not going to be mobile, right? But here we are talking about a router which is inbuilt in the host itself. It is inbuilt in the handheld device itself. The router is also moving along with you. That means paths will break because of mobility. So routing protocol has to be really dynamic. And what all routing protocol that we have studied, right, in computer networks, starting with Bellman-Ford routing algorithm, OSPF, right, and many other routing protocols, they will not be able to cope up with this mobility in mobile ad hoc networks for routing purpose. Hence, there is a need to look into routing protocols. Either you modify them, either you come up with new routing protocols which are suitable for mobility in mobile ad hoc networks. And you can see in this diagram, right, there is a diagram here. So there are 4 nodes over here. There are 4 nodes over here, and I have shown the radio range of all these nodes in the form of a circle, right? This is a radio range means that is a coverage area of node A. That means when I speak, right, what is the area that it is going to cover, right? This is a assumption, right? It is going to be circular, but in reality, it is going to be irregular in shape, right? But for the mathematical purpose, we use circle, we use hexagon, and so on and so forth. But I have used here a circle. So you can see here, node A can speak to only node B directly because node B is in the vicinity of node A's circle. Similarly, when you look at node B's vicinity, right, it can cover up to here. So node B's vicinity is, it can reach up to node A as well as node C, right? But it cannot talk to node D directly. Similarly, node C is, it can talk to B as well as D, and C can talk to only, D can talk only to C. Now the question is, when A wants to communicate with D, then what is the option, right? That means A has to initiate a process of route discovery, and then it tries to find a path, right? A to B, B to C, and then C to D. This is how A is going to establish a path with D with the help of intermediate nodes, right? Right now we were calling it as host. Now we call it them as a nodes because it is a host plus router also, extra functionality. Because B is now acting like a router over here for A and B. C is also acting like a router for this. So as long as all these 4 nodes are static, the situation is better because you have established a path. Now you can start transmitting the data and the smooth communication is going on. But the real challenge comes, what happens if all these 4 nodes are mobile, right? Suppose let us say A is also moving, let us say D is also moving, let us say B and C are fixed, right? So what happens is when E is trying to transmit data to D after establishing the path, D has gone out, right? But A is still transmitting the packets. So it takes some time for A to know that the destination D is not in the vicinity of C right now. That means the link between C and D is broken. So that means now you have to look out for where is D. And then only it is possible. That means you have to again search for the path. You have to locate D and then you have to search for the path and then you have to start this communication. That means packet losses are going to happen at C because C and D link is broken, and that information has to be conveyed to A, and A has to start the process of rediscovery once again. So that means mobility brings really a challenge at the routing level in the first place. Then we'll see what are the other issues, right? So why an ad hoc network? Why this type of network is required? Because it does not depend on pre-existing infrastructure. Why we are talking about pre-existing infrastructure? Because some of the places, for example, you say that in India, Leh and Ladakh, right, where the temperature is minus 30 degrees, minus 40 degrees, minus 50 degrees sometimes, right? So is it possible really to go there and erect a tower, right, and then have this communication possible? Even if you do it, but it is in the borders between our country and some other countries, so there is always a threat, security threat. So that maybe a signal from our side may reach to the other side, enemy side also. So hence it is not feasible like to have a tower over there and have a communication possible. So is it possible to have something like ad hoc network whose coverage area is limited, right? And then ease of deployment, because whenever I need it, I establish it. Whenever I don't require it, I can remove it. And then hence it is speed of deployment because there is no much planning is required to establish this type of network once it is successful. So it leads to a paradigm called anytime, anywhere, any device network paradigm. So this is an example like though only laptop devices symbols are shown here, any device with a wireless interface can become a part of the mobile ad hoc network. And communication between nodes may be single hop and multi hop. For example, you can see here these two nodes, right? This line indicates they can communicate directly because they are in one hop away. But this node, if it wants to communicate here, then it has got a number of options over here, right? That means it can go like this. It can also come like this, right? It can also go and take like this. That means there are a number of alternate routes are available. So based on certain criteria, maybe bandwidth, maybe number of hops, and the routing protocol has to take a decision and then how to reach it there. That means each of the nodes must act as a host as well as a router to make this ad hoc network really a possibility, because there is no special designated router available in this particular network. Then what are the typical applications, right? Though in late 1960s they started with military communication disaster management, now the number of applications have increased, right? Once it becomes a reality, the number of applications can be many, right? The military is still there, disaster management, emergency operations is still there. Then people have envisioned that is it possible to use it at our homes, personal area network, PANs, right? Personal area network. People are talking about laptops in the house, various devices in the house. Is it possible to connect them together and then use it like a ad hoc network or maybe any other network and connect it to internet also, so that you can control them from wherever you are. Then you can also use for meeting rooms, sports stadiums, hospitals, and education also, right? Virtual classrooms, conferences, right? Conference for a day, 2 or 3 days. You can also use this type of things. And other branch of ad hoc networking which is coming up is sensor network, right? A lot of research is going on in sensor network which can be used in the homes, environmental applications, and so on and so forth. So the applications are many, but we need to look into the challenges which are still available so that this technology becomes a reality one day. So what are some of the challenges, right? And you will find that one of the biggest challenge, as well as it is also a fact, is the first one is limited wireless transmission range, right? For example, you take me, right? My voice cannot reach Tamil Nadu, definitely, right? Without the help of this mic and internet facility that we are using. So if I don't have any facility, if I have to only speak, right? Only the participant sitting in Chandigarh only can hear my voice. That's a limitation of my wireless system, right? And you people will be wondering that this wireless communication is very new because we are teaching you during this mobile ad hoc networking. And I tell my students also in the MTech class, I used to ask this question, how old is wireless communication, right? Some people say 25 years old, some people say 50 years old, some people say 200 years old. Then I told them that wireless communication is as old as all of us, right? As old as your parents, as old as your grandparents, right? That means as and when the life is existing in this earth, wireless communication is going on. That means the way the child and the mother speaks is through wireless communication. Only thing is, with the help of this technology, we have crossed the boundaries, right? Because of now the technology, I am speaking here, you are able to hear, right? Through wired, wireless, whatever it is. So limited wireless transmission range is a fact as well as it is a challenge. So with this fact, with this challenge only, we have to make the communication possible. We have to make the networking possible. So assuming that limited wireless transmission range is a fact, we have to accept it. And then what are the other issues that need to be addressed to make this technology really a possibility? One is broadcast nature of wireless media, right? For example, I am speaking here and whoever is sitting in Chandigarh Center, all of them are here, right? That is the way we communicate in a wireless media, right? One speaks, whoever is there in the vicinity of me, they all will be hearing my signal. Either they are intentionally hearing or they are overhearing, right? Sometimes students are doing some work, but still I am shouting here, so they also hear my voice. That's the choice is between them, right? Okay. So broadcast nature of the wireless medium is good as well as it is bad also. From the networking point of view, it is bad because it creates two problems in the network. One is called hidden terminal, other one is called the exposed terminal problem. These two problems has to be handled at medium access control layer. So MAC protocol, whatever you design, especially for ad hoc networks, especially for wireless networks, you have to see that your network is free from hidden terminal problem, your network is free from exposed terminal problem. We'll see in the later slide what are these two problems, right? And this problem is not existing in a wired network, right? You take example of Ethernet, you take example of fast Ethernet, you take the example of gigabit Ethernet, hidden terminal problem is not there, exposed terminal problem is not there. But when you go to a wireless network, this problem exists. Hence, your MAC protocol has to be really smart and it has to address these two issues. And we will see if these two problems are present, what is the result of it, what is the bad about it in the network. That we will see in the later slides. Then the specific problem for wireless or mobile ad hoc networks is mobility-induced route changes. That means route which you have established, as we have seen in the earlier slide, between A and D. If all the nodes are moving, the routes are going to break frequently, routes are going to be made more frequently. That means routing protocol has to really cope up with these changes, with these modifications. Hence, routing is also an important issue. That means you need to have either modify the existing routing protocols, or you have to create a new routing protocols, and so on. So routing is a big challenge because mobility of nodes. And here node is, it is a host as well as a router. That means router is also moving, right? Then it's a big challenge. Then other one is a transport layer problem, right? So far the existing transport layer, when you talk about TCP and UDP, packet losses are considered only due to transmission errors, right? But when you talk about mobile ad hoc network or wireless network, packet losses are also due to node mobility. As I told you, when A has established a path with D, what happens if B or C or D has moved out? Path has been established, right? Till that time you get the information that a path is broken, the packets which are being queued at C as B or D, they are all lost, right? That means packet losses are happening due to node mobility also. That means your existing TCP is basically designed for taking care of transmission errors. Based on that, it takes the congestion window, right? Whether congestion window has to be reduced or congestion window has to be increased. But it doesn't have a capability to take care of the mobility aspects, right? Mobility aspect is also leading to packet losses, which is not addressed in the traditional TCP. That means even the TCP has to be modified, or you have to come up with the new transport protocols for ad hoc networking purpose. So transport layer is also a problem. Then the other important problem for any wireless device is energy efficiency, right? Your mobile phone, your laptop, all are battery constrained devices. That means if you design a MAC protocol, it has to be energy efficient. If you design a routing protocol, it has to be energy efficient. If you design a transport layer protocol, it has to be energy efficient. If you design application layer protocol, all protocols which you design for wireless network, particularly for ad hoc network, it has to be energy efficient. Power saving, energy efficiency, and one of the important issues. Then another issue is security, right? As long as the signal is propagating through a wired medium, a guided medium, right, your signal is protected some extent or great extent from the security threats. But once you radiate the signal into space, right, the security issues are going to be more. That means when we see the OSI model or TCP IP model, we have seen that in the application layer, each of the applications, depending on the requirement, they have a security protocol. For example, you take SSH, right, secure shell. It is basically a secure version of Telnet, right? That means the remote login facility, Telnet and SSH. So depending on the requirement, there is a security version of it. Similarly, for email, you have PGP, Pretty Good Privacy, or SMIME, right? So that is again specific to email application. So similarly, for many more applications, depending on the requirement, you have a security mechanism. Then later on, people have realized that you need to have a security mechanism between application layer and transport layer. Then they came up with the idea of secure socket layers, right? SSL technology. And you will find this SSL in many of the e-commerce websites, right? You go to any banking website, right? SBP, onlinesba.com, ICICIbank.com. On the homepage, you will find that this site is SSL 128-bit encrypted, right? So this is a sub-layer which has been introduced between transport layer and the application layer. That means application layer, depending on the application protocol, requirement of security you have introduced. Then you have introduced SSLs also. Then Internet Architecture Board, IAB, they have introduced a security called IP security at network layer. That means application layer you have security, transport layer and application layer you have SSL. Then at network layer you have IP security. Then when you come to the wireless, right, IEEE 802.11, then you have a security even at the MAC layer, right? Whenever whoever is using a Wi-Fi services through their laptops or desktops or maybe through mobile phones, you are always asked to set a security mechanism, right? A password, right? Simplest could be you put a password, right? It's called as a pre-shared key. Pre-shared key can be used, or you can also go for WAP, right? WPA you can go, WEP you can go, WPA1, WPA2 also you can go. So security is required even at the data link layer. That means your application layer has to be protected. Transport layer and application layer you have SSL. Then network layer you have IP security. Then data link layer, particularly for wireless network, you have WEP, WPA1, WPA2, WPA, right, and PSK also, right, pre-shared key. So all options are available. So that means every layer, in fact, right, in the TCP/IP traditional model has to be secured when you talk about a wireless networks. Then we'll see briefly about what are the physical layers, right? Why I'm touching about only 802.11 is because 802.11 is widely used in the test beds and simulations of ad hoc networking. Hence, I am taking this 802.11 for explanation purpose. Otherwise, you can also use a hyperLAN, a competitive standard for 802.11, high performance radio LAN, hyperLAN, HIPER. HyperLAN is also available, right, which is a ETSI standard. Hope you are able to catch it up, right? Maybe I am going faster because I am not able to see many students in front of me, right, physically, except 3 people. Otherwise, I love to have the interaction, right, during the class much. But because it's ICT based classroom, maybe we'll have interaction at the end of it. So ETSI. So you have ETSI. ETSI is European Telecommunication Standards Institute, which has given a number of standards, and one of the standard is hyperLAN. Even the GSM, right, that you use on your mobile phones, GSM is also from ETSI, European standard, which we are using in India also. So hyperLAN stands for high performance radio LAN, which is given by ETSI. So this is also a wireless LAN technology. This is also a wireless LAN technology, which can be which can be used for wireless LAN purpose. But 802.11 is more popular because it has come early before hyperLAN. So we will be talking about only 802.11 standards. I will not be touching on hyperLAN. Those who are interested, you can always go through these hyperLAN standards also. So you will find IEEE is having working committee on 802. 802 is having a number of series of standards, right? 802.1, 2, 3, 4, 5, right? 3 is familiar to us. 802.3 is Ethernet standard. 802.4 is token bus. 802.5 is token ring, which we might have studied in computer networks by Tenenbaum book also and other books also. And 802.3 is still popular, right? With different names, right? Fast Ethernet and Gigabit Ethernet. But we are more focusing on the wireless LAN standards. So wireless LAN standard starts from 802.11. So 802.11 is the basic standard, which has come up in 1995, around 1995, which talks about physical layer and medium access control layer. So if you look at the traditional OSI model, data link layer is basically only one layer, but it is a IEEE 802.3 working committee, which has split this data link layer into 2 parts. One is medium access control, other one is the logical link control. So logical link control is closer to network layer and medium access control layer is closer to the physical layer, right? So it is IEEE which has divided this data link layer into 2 subparts, physical layer, MAC layer and logical link control. So we are using the same thing in 802.11 also. So it talks about physically, naturally, right? When you talk about 802.3, it is a wired Ethernet, right? So when you go to the wireless LAN or wireless version of Ethernet, so naturally physical layer, definitely you need a change. That means physical layer has to be changed because the communication is going to be through the antennas. And the question is why we should change even the MAC layer, right? Medium access control sub layer. Because when you look at the Ethernet in the medium access control sublayer, we use CSMA and its variants, carrier sense multiple access, along with collision detection and the various versions of it, right? But here is the question that why IEEE 802.11 committee has changed even the MAC layer also. That means they have deviated from carrier sense multiple access with collision detection to some other mechanism. Whereas CSMA CD is still popular, right? Which has been designed somewhere in 1971-72. That means almost 45 years old. But this technology is matured and it is successful. Still, it is being used in various versions of Ethernet. But why the IEEE 802.11 committee has not used CSMA CD and why they have changed even the medium access that we will see in the later slides. Then 802.11, the basic wireless LAN standard, has been designed with a maximum data rate of 2 Mbps. Maximum data rate is very important because it is a wireless standard. The data rate depends on the quality of the signal. If the signal strength is excellent, right, there is a possibility of getting the maximum speed. If the signal strength goes down, automatically your speed comes towards zero side. That means from 2 Mbps towards zero side, that means you are going to be disconnected depending on the, just like your mobile phone, right? If you have good signal strength, your quality of communication will be better, voice communication is better, data communication is better. But if you don't have a good signal strength, then automatically your quality of communication goes down. Same is the case for wireless LAN also. So 2 Mbps was not a good speed, right, in 1995, 1996, because we already had a Ethernet in 1996 also, a standard Ethernet or classical Ethernet, which was offering a speed of around 10 Mbps with the help of wires, UTP cables. So, and then Ethernet group was considering to go towards fast Ethernet, that is from 10 Mbps to 100 Mbps. And during that time, this 1995-1996, wireless committee came up with the idea of 802.11 with a maximum data rate of 2 Mbps. So 2 Mbps and a coming standard of 100 Mbps with wires. So there is a sea change, right? 2 Mbps and 100 Mbps, there is no comparison. But the advantage is one is wireless, other one is wired, right? And the question is the bandwidth. And users are so hungry for bandwidth, right? I was just telling that we are carrying out a campus-wide networking here, upgrading our backbone network to 10 Gbps, right? Work is going on. And some of the residential areas, because we have given internet at the residential areas also, an entire campus. In the hostels, we have given Wi-Fi facility. For last 2 days, the internet is not working in the residential area. And so many people have called me, right? Those who are not calling me earlier for any purpose, they started calling me. So why the internet is not working, when the internet will be up, right? I told him that, are you getting water in your house? Sir, water is not required, sir, first internet is required. That is the status now, right? Once the internet is working, then they will say that it is very slow, because I am not able to transfer the video, I am not able to watch video, I am not able to send email, I am not able to download file. That is the status of bandwidth. That means user is hungry for bandwidth. First, we had 100 Mbps internet bandwidth from NKN. Now 100 Mbps has been choked for last 1 year. Then we have followed up this NKN, NIC, right? And then finally, for last 4 or 5 months before, they have upgraded our network to 1 Gbps. Right now, we are occupying around 400, 500 Mbps. And I am sure that another 1 year, this 1 Gbps also will be filled. Right? You have so many applications, right? People have become so savvy for internet, right? Without watching Facebook, without watching email, right? You will never go to sleep, right? Food is secondary. First is Facebook, right? Next is WhatsApp, right? And other so many applications are available on the internet. After that, only you go to bed, right? After taking food, you will go to bed. So that's the importance of internet bandwidth. That is the importance of networking. That is the importance of our impact of internet on the people's lives. So bandwidth is very precious. So 2 Mbps and 100 Mbps, right? One is with wires, other one is without wires, right? So finally, what happened then? 2 Mbps wireless LAN was never implemented, right? That was, there is no card which came into the market with the pure IEEE 802.11 2 Mbps wireless LAN card. You will not find anywhere in the market. It never came into the market. That's the reason you will not find it in the market also. Because the reason that the bandwidth which is offering is only 2 Mbps maximum. Hence, original IEEE 802.11 wireless LAN card never came into the market. because fast Ethernet was under consideration. Then they had an apprehension that this technology may not become successful, this card may not become successful. Hence, they were looking out for, is there any way at least to bring this wireless LAN to 10 Mbps, at least. Because standard Ethernet also was 10 Mbps, but that is with wires. And if it is possible through wirelessly to come to a 10 Mbps speed, then what they have done, they have come up with serial number 3, not 2 came later on, that I will tell you later. Serial number 3, that is 802.11b. 11b is basically an enhancement to 1, 802.11. So 802.11 is 2 Mbps maximum speed, and 802.11b, that is serial number 3, is can go up to 11 Mbps maximum speed. What changes they have done? Only the physical layer is modified. That means MAC layer is intact. Only the physical layer is modified. That means the modulation schemes have been changed to increase the data rate from 2 Mbps to a maximum of 11 Mbps. So hence, the people were convinced that standard Ethernet with wires was offering a speed of 10 Mbps. People were to some extent happy. So is it possible now without wires, can we release this as a LAN card into the market? And 802.11b is the first wireless LAN card which has come into the market, and people started using it because it provides a maximum data rate of 11 Mbps, of course subject to signal quality and signal strength. So the first card is 802.11b with the modifications to the physical layer, and MAC layer is as same as 802.11 that we will see later. Then, as I told you that earlier we had, right, 1 year before 100 Mbps internet bandwidth, people have choked it completely, right, because of various number of applications and demands from the users. And then we have given it to the entire students community, right? Students go, whatever bandwidth you give them, they will fill it up, right? They have many applications to run on this network. So now 1 Gbps has come, that also almost half of it is already occupied, right? Maybe another 1 or 2 years, we have to ask again and again to make it to 2 Gbps, right? If not 1.5, at least 2 Gbps is required, and it goes on. So same is the case with this wireless LAN also. 11 Mbps, people were happy for some time, right? Then the fast Ethernet came into the market, 100 Mbps, right? Wired Ethernet is 100 Mbps, wireless Ethernet is 11 Mbps, right? There is a stiff competition between both the technologies. Both are from IEEE group only. Then later on, IEEE 802.3 committee, right, which has designed this fast Ethernet, they were considering to make a gigabit Ethernet. That means 100 Mbps to 1000 Mbps speed, 1 gigabit Ethernet. So once IEEE 802.3 committee started thinking for 1000 Mbps Ethernet, then wireless LAN again started fearing, right? What will the status of 802.11 be, right? Who will be offering, right? 11 Mbps speed and 1000 Mbps speed. One is with wires, other one is without wires, right? And as I told you, people are hungry for bandwidth, right? They want to see a live cricket match, right? On their laptops, on their mobile phones. That's status, right? That means you need to have better and better bandwidth. Then what they have done is 802.11b committee, right? 802.11 committee, they came up, is it possible to increase this data transmission rate further, right? Instead of 11 Mbps, is it possible to make it towards 100 Mbps? Then they came up with this serial number 8, 802.11g. Again, they have modified the physical layer, right? What they have done, this time they have introduced a new technique called OFDM, orthogonal frequency division multiplexing. Orthogonal OF. Is it visible? Sorry, right? 1 minute. 1 minute. Sorry. Yeah, it is OFDM. So orthogonal frequency division multiplexing has been introduced in 802.11g. That means physical layer has been modified with the help of OFDM. And then in G, they could achieve a maximum data rate of 54 Mbps. That means almost half of fast Ethernet speed, that is 100 Mbps. So that is the reason you will find in the market that LAN cards available with IEEE 802.11b/G. That means it is backward compatible with 11 Mbps as well as forward compatible with 54 Mbps speed. Right? By the time gigabit Ethernet came into consideration, right? And then people started worrying that gigabit Ethernet 1000 Mbps and 54 Mbps. Wirelessly 54 Mbps in 802.11g, but with wires gigabit Ethernet of 1000 Mbps. Then is there any way to compete with gigabit Ethernet? Though I have not listed here, there the standards are coming up. You can write down and then maybe you can explore it right on the internet and see standards such as 802.11 AC, 802.11 AD are under consideration. Are under consideration. So when you give a Google search for 802.11 AC, 802.11 AD, then you will find that these are wireless gigabit networks. Right? Already some trials have been done. They can go up to a speed of around 7 to 8 Gbps wirelessly. Right? 7 to 8 Gbps wireless speed. So that is under trials, right? NTT Docomo has done some trials. Samsung has done some trials. Right? Look at the internet, then you will find that what developments are going on in the wireless LAN technology. Then the other interesting standard that which I would like to highlight is one is serial number 6, 802.11e. Other one is serial number 10, 802.11i. So once your wireless LAN is in place, B/G, right? Then the concern came for security. Right? Original 802.11 was using a security mechanism called Wired Equivalent Privacy, WEP. And it has been demonstrated, and we have also demonstrated to our students, right, during the class time, that WEP can be cracked in less than few minutes. Right? If any one of you are using this WEP setting in your wireless LAN card, WEP can be cracked in less than in few minutes, right? Let us say less than 5 minutes or less than 10 minutes, you can break it. That means WEP is not at all safe when you are setting to wireless LAN mode. Then the IEEE came up with a security enhancement that they gave a name of 802.11i, and this security enhancement has come up with an option of WPA, Wireless Protected Access. WPA you have WPA 1, WPA 2. You also have something called PSK, pre-shared key, right? So either you can set it to pre-shared key, just like in our wireless LAN we are using pre-shared key, because ours is a two-tier security mechanism. One is pre-shared key we are using. When any wireless device which wants to become a part of our network, first they should know the pre-shared key. Once they get the pre-shared key, they become the part of our network. Then we have a FortiGate firewall, right? Then you have to have another username and password, which is given by the network administrator. So then you have to get through that also, then only you will be able to use our services, right? So 802.11i is also an important standard, which is being used in the 802.11 technology. Then, as I told you that in the beginning when the 802.11b came up, it was only basically, right, checking some emails, right, and downloading some document and all those things. But later on, people started going for multimedia services, right? Multimedia services over a wireless LAN. That means your traffic is going to be different. You have a data traffic, that means simple file download, or you can also have a audio services. You can also have a video services. That means your type of traffic is different, right? Video and data cannot be treated at par, right? Video demand is different, audio demand is different, quality of service requirements are different. Hence, IEEE has designed an enhancement to 802.11 in the name of 802.11e, which talks about quality of service enhancement in the MAC layer. So now that means you have 802.11b/G, which takes care of E as well as I also, depending on the requirement. And then one I told you that serial number 2, 802.11a. A has come after B and J has come, right? BG operates in 2.4 gigahertz ISM band, right? B and G operates in 2.4 gigahertz ISM band, and A operates in 5 gigahertz band, right? A is having a similar characteristics of G, right? G also offers 54 Mbps speed, OFDM technology, and A also offers OFDM along with that 54 Mbps, but the frequency band of A is 5 gigahertz, but B and G frequency band is 2.4 gigahertz. Then this IEEE 802.11, right? It operates in two standard modes. One is called infrastructure-based wireless LAN with the help of access. This is what you will see in every institute which is having a Wi-Fi, right? So Wi-Fi is always configured in this mode, infrastructure mode. That means you will have access points, you have wireless routers, wireless bridges. Then you establish your Wi-Fi network within your campus. But what we are more interested in the second option, infrastructure-less ad hoc networks. Right? I do not know how many of you have seen that the laptops with the wireless LAN card. You go for the configuration setting and then you will find that it is having two options. One is infrastructure-based wireless LAN. You want to become part of it, or you want to become a ad hoc network part. That means if you choose the second option, then you can form an ad hoc. That means you can bring the laptop, few laptops in your classroom, and you set it to ad hoc mode, and then you can start exchanging the files among your machines without any wires, without any access point even. That is what is infrastructure-less ad hoc network, which is also available in wireless. But the disadvantage is it is having a limited mobility. IEEE 802.11 is having a ad hoc networking mode in its card, but with a limited mobility. Limited mobility means maybe maximum of walking mobility. That means I can carry my device and I can walk, right? But definitely I cannot carry it in a vehicle at a greater speed. That's a limitation of it. That's the reason ad hoc networking challenges are still prevalent, and we need to look into it. This is an example of IEEE 802.11 based infrastructure based wireless LAN. You can see here there are few wireless devices here, right? So laptop is written here. Any wireless device with a wireless LAN card can become a part of it, right? This is called a basic service set, which is called BSS. Then there is a device here, right, which is shown in blue color. This is access point. Access point is having two interfaces. One is a wireless interface for these wireless devices. Other one is it is having a wired interface which is connected to your regular Ethernet, right? So you can see here there is a wire line here. So there is another PC connected here, desktop PC here. So this access point is one side connected to your regular Ethernet, other side it is serving your wireless devices. So as long as this access point is active, all these wireless devices will be able to communicate through the regular network, as well as they can become part of internet also. But once this wireless access point is a failure, then all these devices will be cut off from the network, right? If they don't have a wired facility. So this is entire area is called a basic service area. This is an example of an infrastructure-based wireless LAN. Next is a infrastructure. This is of interest for us, right? When I don't have an access point, is it possible that I can create a small network, wireless network, and then start exchanging the communication? Here in this place, you can see that only wireless devices are available, which we call them as a independent basic service set. Independent means there is no dependence, right? There is no dependence on anything. So these devices have come together and they want to form a network. So with the help of this infrastructure-less ad hoc network mode in the wireless LAN part, you can configure these devices and then they can start communicating, they can start exchanging the data. This is called an infrastructure-less ad hoc network, but with a limited mobility. But what we are talking is a mobility which is really a possibility moving in a car, right? Is it possible that I can use it? So these are some of the general physical layer specifications of 802.11. You can see here 802.1, the basic standard, 2 Mbps standard, right? You can see here data rate is 1 Mbps and 2 Mbps. 2 Mbps is the maximum speed, right? And the minimum is depending on the signal strength. That means it can have a step down of 2, 1, and then partially, and then it gets disconnected, right? Okay. And then it operates in 2.4 gigahertz band. 2.4 gigahertz means it starts from 2.4 and it can go up to 2.4835 gigahertz. That means bandwidth that is available in this frequency band is 83.5 megahertz. So in this 83.5 megahertz, you have 3 non-overlapping channels, right? Total number of channels are around 13 or 14, right? But they are overlapping. But non-overlapping is only 3. That means at a time within the vicinity of one campus, you can have 3 independent wireless LANs because 3 frequencies are non-overlapping. If they are overlapping, that means there is a possibility of interference, right? And then this uses a transmission scheme of frequency hopping spread spectrum, direct frequency spread spectrum with QPSK as a modulation technique. Then you will find this 802.11b, which is the actual standard which is implemented, right? This standard was never implemented, but this is implemented, right? Same frequency band, 2.4 to 2.4835, 3 non-overlapping channels. But you could see here a data rate is up to 11 Mbps, right? Here you can see that 1, 2, 5.5 and 11 is returned. This is called auto rate fallback. Auto rate fallback. right? This is called adaptive auto rate fallback. The feature called auto rate fallback. Auto rate fallback means, as I told you, that the speed is depending on the signal strength. If you are getting the best signal strength, right, then your speed may go towards 11 Mbps. If the signal strength is coming down or signal quality is going down, then automatically your wireless LAN card, right, switches over to a lesser speeds, 5.5 to 1, and then it gets disconnected also depending on the signal quality. This is called a auto rate fallback mechanism, which is inbuilt and which is automatic. No user intervention is required. So as I told you, that physical layer has been modified with DSSS is still there, but they have used QPSK and complementary code keying modulation techniques. Complementary code keying. Complementary code keying. Details you can search it out, right? Because I told you that I'm not going to go into the schemes, right? Various schemes. Complementary code keying. KEYING. Right? Complementary code keying. So with the help of this physical layer changes, right, IEEE 802.11b working group could go up to 11 Mbps data rate. This is some brief about 802.11 and 11b. And then A you can see here, right? Right. Though G I have not seen here. G is frequency bandwidth is same, frequency is same, number of overlapping channels is also same. Only thing data rate is it is up to 54 Mbps, but the transmission scheme is OFDM, right? Orthogonal frequency division multiplexing. So 802.11a, when you look at it, right, it is operating in 5 GHz band, right? There are two separate bands here, 5.15 to 5.35, 5.725 to 5.825. That means more bandwidth is available. That means more number of non-overlapping channels are available, right? That is 12 non-overlapping channels are available in 5 GHz, but in 2.4 you have only 3 non-overlap. But here you can see it can go up to 54 Mbps just like your 802.11g, right? With OFDM, with PSK and quadrature amplitude modulation techniques. That means this data rate and transmission scheme is same in 802.11a as well as G, but the difference is the frequency band. That's the difference, right? With number of non-overlapping channels. Then you might have seen it in the market also, right? People are now talking about 802.11 B/G/N, right? B/G/N. People are talking about 802.11 B/G/N. So we have seen that B and G can go up to 54 Mbps. As I told you that we are hungry for bandwidth because we have number of applications which needs more and more bandwidth. So N can go up to a 600 Mbps data rate, right? A maximum of 600 Mbps because it uses a technology called multiple input, multiple output, right? Instead of using a one single transmitting antenna and single receiving antenna, is it possible to use multiple transmitting antennas and multiple receiving antennas, which is called a MIMO, right? Multiple input, multiple output. So if you are using 4 streams, right, then you can go up to 600 Mbps. If you are using only one stream, you can go up to 150 Mbps, right? Depending on the number of streams that is provided in the card, which is coming in the market, either you can have 150 Mbps speed or you can go up to a 600 Mbps speed. Now you also might have heard about a standard called 802. There are a number of standards, right? 802.15, right? 802.15 is called a wireless personal area network, right? Wireless personal area network, WPAN, wireless personal area network. In this also you have a number of options, right? 802.15.1, then you also have 15.2, 15.3, high rate and low rate, right? High rate and low rate wireless personal area networks. Then you also have 802.11p, right? 802.11p, which is also called as wave, right? Which is also called as wave Wave is wireless access in vehicular environments. Wireless access in vehicular environments, or it's also called as intelligent transportation system. Right, a technology which can be useful in intelligent transportation systems, which is called as 802.11p. Right, this is also called as in the literature vehicular ad hoc networks, VANETs. Right, we have MANETs, mobile ad hoc networking. Now people are talking about vehicular ad hoc networks, and one of the standard which will assist you in simulations and test beds is 802.11p, which takes care of this to some extent, which is also called as intelligent transportation system. So there is a need for more and more data rates. That means you have to explore for more and more physical layer schemes, which can assist you really to go for better and better speeds, which will satisfy the demand of the users. That's brief about physical layer issues with respect to ad hoc network. Then the next issue is we need to address is the medium access control layer. And as I told you that medium access control layer is needed because wireless channel is a shared medium and bandwidth is a very precious resource, right? You cannot afford to waste bandwidth. Whatever bandwidth is available, you have to make it the best possible, right? So because it is a shared medium, so there is a possibility of collisions, right? That means more than one station may jump onto the channel, right? And there is a possibility of packet collisions. The whole purpose of this MAC protocol is to control or to avoid packet collisions. To control or to avoid packet collisions. That's one of the major purpose of a medium access control protocol. Or in other words is to maximize the probability of successful transmissions by resolving contention among users. That means whoever wants to become, right, use the channel, they have to compete for the channel access, and whoever wins, they will be able to transmit the data. If more than one user gets successful, right, to access the channel, then that leads to collisions, right? That is the basic purpose of any MAC protocol, whether it is wired or wireless. In the case of wireless network, there is two special problems, which I told you in the challenges also, that hidden terminals or exposed terminals problems also have to be addressed, which is not a part of Ethernet. And the other purpose of this MAC protocol is to maintain fairness amongst all users. That means a user closer to the base station should not be given more preference. A user who is far away from the base station should not be given less preference. All should be treated same if you don't have any priority for any of the stations. That means your protocol has to be smart. It has to be fair enough, right? It should not be unfair with respect to the user's location, right? Near and far. So based on this, you have a number of wireless MAC protocols, right? Not one, right? They are broadly classified into centralized wireless MAC protocols, and then you have a distributed wireless MAC protocols. In the centralized category, you have a number of them, right? You have a random access. Random access you can see on both the sides, right? You can see on the distributed side also. You can see on the centralized side also, right? Then on the centralized side, you have a guaranteed access. Then you also have a hybrid access. So in the case of wireless MAC protocol centralized, that means depending on the architecture, right? If your wireless network is having a arbitration station, that is a control station is available, a central control entity is available, then that scheme is called a centralized wireless MAC. For example, access point, right? The access point is acting like a coordinating agent, right, in the network. So that comes under the centralized architecture. So you have random access protocols also in that category. Then you also have a guaranteed access, right? Guaranteed access means access is guaranteed, but there is no competition among the nodes. For example, token bus and token ring, right? Whoever holds the token or whoever gets the token, they are free to transmit if they have a data, but they are not competing. So access to the channel, access to the network is guaranteed, but how much time? There is a possibility of delay, but the access is 100% sure, right? The token which has been released, which is circulating either clockwise or anti-clockwise, it will definitely come back to each station. Definitely come to each station. But in the case of random access, there is no guarantee, right? You may get access to the channel, you may not get access to the channel, depending on the traffic and other conditions. So other scheme is a combination of both of them, right? Centralized random access, centralized guaranteed access. Take the best of this, guaranteed access and make it a khichdi, right? I call it as khichdi protocol, right? When you fall sick, you make khichdi. So here what we will do, take good of random access, take good of guaranteed access and make a khichdi. That is called a hybrid access MAC protocol. But we are not more interested in these centralized MAC protocols because we are talking about an ad hoc network where there is no centralized control, right? We don't have access point, and we are talking about an infrastructure-less network, no base station, no access point, no router, but still you have to make it a possible. That means all the protocols falling on the centralized wireless MAC protocol are not suitable for ad hoc networks. Hence, we are going to focus on distributed random access wireless MAC protocols. They are suitable because they don't require an access point or any device, a coordination purpose. Hence, random access protocols can be operated in either in centralized architecture or decentralized architecture. So we'll focus on distributed random access wireless MAC protocols. You all might have heard that the simplest distributed MAC protocol is the pure aloha MAC protocol, right? Which you might have studied in Tenenbaum or maybe Forozen book, right? Which is, what is this protocol? Simple protocol, right? I can say there is only one line. The algorithm is only one line. Frames are transmitted as they are generated. Is the pure aloha MAC protocol. That's all is the essence of pure aloha. That means whenever I want to say something, I will say, I will speak, right? I am not worried about whether somebody is talking, somebody is not talking. I am least bothered, right? I am no discipline with me. When I want to say, I'll open my mouth, I will start speaking. In the same way, here also system, whenever the data is generated, it starts transmitting. It is not bothered about, right? Station 2 is transmitting, station 3 is transmitting, or station 4 is transmitting. It doesn't have any mechanism to check, right? You can see here, station 1 started transmitting 1.1, 1.2 frame. And similarly, this is x-axis is the time. Then station 2, 3, and 4 also, if you see that they also are also transmitting, right? Nobody is bothered, right? Station 1 is keep on transmitting, station 2 is keep on transmitting, similarly 3 and 4 also, right? Frames are generated and then they have been transmitted. There is no discipline. But you can see here, even without any discipline also, 2 frames are successful. That is frame 1.1, there is no overlapping, right? It is successful. Then you can also see that frame 3.2, this is also successful, right? There is no overlap of station 1, 2, 3, 4. So, out of so many packets, right, you can see here maybe around 8 packets, 2 are successful. This is just a right hypothetical scenario. Frame 1.1 is successful, frame 3.2 is successful without any discipline. That means whenever you want to say something, you say, still some packets are successful. The rest of the packets you can see here, they are all lost in collision. Right, because your MAC protocol says that it's a shared medium, hence only one station, if it transmits, then only it is successful. If more than one station transmits, all packets will be lost in collision. So then you can see a collision duration has to be decided. How much is the time which is wasted due to collision? That is called the collision duration. Based on that, you decide the throughput of the protocol. How to decide throughput of the protocol? There is some simple mathematical model, right, which I'm not going into the details of this. This you can read it from anywhere, right? And this is called the modeling of the MAC protocol, right? So here we are assuming that the packets are arriving into the network with a Poisson distribution, and packets are being serviced or leaving the network with a exponential distribution. So with that assumption, we can find that the right throughput is basically offered load, that is how many packets or frames that you have offered into the network, and what is the probability of their success. Probability of success multiplied by the number of frames that you offer to the network will give you, right, g into e to the power of minus 2g, right? Now, yes, right. You have some question? Okay, right? Okay, we'll take the questions at the end. So this is a standard pure aloha throughput equation, right? So S is for throughput, and you can see that g into e to the power of minus 2g. If you want to find out what is the maximum throughput which is available in pure aloha, you maximize this equation. That is ds by dg. You differentiate it and equate it to 0. You will get a value of g, and g value is 0.5, and then this value you put it here, then you will get the maximum throughput. So maximum throughput which is for pure aloha is 0.184. That means it gives a 18.4% maximum throughput. What is the meaning of it? That means if I have offered 100 frames into the network over a period of time, only 18 frames are going to be successful on average. Only 18. But the interesting thing is, this protocol doesn't have any discipline, right? Frames are being transmitted as they are generated. So without that also, no discipline, it could give you a maximum throughput of 18.4%. right? It is a very interesting protocol. Then our aim of throughput is to make it towards 100%. Any network, any protocol that you design, MAC protocol, your target is it possible to offer theoretically, ideally 100% throughput? That means target is towards 100%. So this 18.4% is very far away from 100%, right? Hence, people started, right? Researchers like you and me, we thought that we are doing a literature survey for our PhD work, MTech thesis work. Is it possible to make this 18.4% towards 100%? That's the question mark. Then, right, one of us got an idea, right? Instead of making no discipline, is it possible to make some discipline, right? Is it possible to make some discipline, right? Discipline is always good. So what discipline we have brought? We have changed the algorithm, right? Few words we have changed. Frames are transmitted not as they are generated, but only at the beginning of slot boundaries, right? As you can look at this diagram compared to the previous diagram, here station 1, if it gets a packet or frame, it has to wait for the beginning of the slot. Now the time is divided into slots. In earlier diagram, time was not divided into slots, right? So here, even if this station gets a packet in between this time slot, right, it has to wait till the beginning of this boundary. It cannot transmit there itself. So that discipline we have brought in, and by doing this discipline, and we have found that the throughput has been doubled, right? That's what you can see in this diagram, in this equation. The throughput is defined now as G into e to the power of minus G, whereas in the pure aloha it was G into e to the power of minus 2G, right? That means if you differentiate this equation and maximize it, putting it to 0, G will become 1, right? So when G becomes 1, the S max will become 0.368. In the case of pure aloha, it was 18.4%, but here in the case of slotted aloha, it is 36.8. The reason is very simple. You have reduced the collision duration by half. In the case of pure aloha, the collision duration was 2 slot durations, but in the case of slotted aloha, it is only 1 slot duration. That means you have reduced the collision duration by half, hence your throughput is multiplied by 2. Right? That's good. Right? 36.8% is a good throughput, but it is very far away from 100%. So then again, right, another MTech student and PhD student thought that, is it possible to take it towards 100%? So what they have done, this is the right plot of this throughput versus upward load for pure aloha and slotted aloha. You can see here maximum throughput is 0.368 at G equal to 1 for slotted aloha, and maximum throughput is 0.18 for at G equal to 0.5 for pure aloha. Right? This is what I have shown diagrammatically. Same thing, right? Then the people thought that how do we communicate in a conference room, right? As human beings, right? You have a round table conference room. How do we calculate? How do we communicate, right? With a audio system, right? You might have seen good conference rooms. Every table is having a mic, and also that mic is having a button, right? Whenever you want to say something, you need to press that button, right? Once the button is pressed, the red light will go on that mic. That means everybody who is watching you gets an indication that maybe Ramakrishna wants to say something. That the meaning is, I am going to say something, and the meaning to other people is you have to keep silent. You have to keep silent. We assume that our conference room, all the people are disciplined, right? They are not violent people. Hence, it gives a message that so and so person is going to speak, and they are supposed to keep silent. So, is it possible to introduce the same thing in a network in the form of medium access control protocol? That we call it as listen to the channel before transmitting a frame or a packet, which is better discipline, right? The name that is given is carrier sense multiple access. Carrier sense multiple access. And CSMA does listen to the channel before actually it transmits a frame. And it has been proved theoretically, right? It gives you 100% throughput. It gives you 100% throughput, but with a condition. What is that condition? Right? Most of the literature and books writes it as A, right? So I will also use it as A only. A equal to propagation delay by packet transmission time. This has to be equal to 0. Right? A, propagation delay divided by packet transmission time has to be 0. Now you have to tell me, is there any channel is there any channel whose propagation delay is 0? Because packet transmission time can never be 0, right? Packet is of some finite size, your data rate is of finite size, hence packet transmission time is always a finite in time. It is the only propagation delay which has to become 0, then only A becomes 0. That means propagation delay is decided by the channel. So if you can tell me a channel whose propagation delay is 0, right, I can assure you that CSMA will give you 100%. If you say that I don't have any channel which gives you propagation delay 0, let us say that it gives a propagation delay of 0.0001, then I will say I will give you 99%. If you say that my A is 0.1, right, then I will say that I will give you 90%. Right. So if the propagation delay, if you can assure me, right, with the channel, then I can give you 100% throughput. So CSMA is an excellent protocol, carrier sense multiple access. That is the reason, right, 1971 onwards, right, till today, CSMA is used along with the CD in the Ethernet. Hence, it has got a number of varieties of anyway, right? Sorry. So CSMA is a better candidate, right, in terms of throughput and quality of service parameters. So hence you will find a number of flavors of carrier sense multiple access, right? One is a non-persistent CSMA. Another one is a persistent CSMA. Non-persistent means it will not persist with carrier sensing if the channel is not available. That means the basic principle of carrier sense is before you actually transmit a frame or a packet, you are supposed to sense the channel. So non-persistent means it definitely senses. If the channel is busy, it goes back into waiting mode. Right? That means it is not very hungry that I need to capture the channel. Persistent means it is very hungry, right? It is very demanding that it has to transmit a packet. That persistent depends on one persistent or P persistent. So this P stands for probability. If P is 1, then it becomes one persistent CSMA. One persistent CSMA means it will be keep on sensing the channel continuously, right, till it gets access to the channel with probability 1. P persistent means it may persist for some time. If the channel is busy, with the probability P, it may go back. But if P is 1, it will be continuously sensing. So one persistent CSMA is used in your Ethernet also. One persistent CSMA is used widely in the Ethernet. And P persistent is for theoretical purpose, definitely yes, right? Non-persistent is also very less used. And other variation is time can be slotted or non-slotted, right? Then you can have a unslotted non-persistent CSMA, slotted non-persistent CSMA, unslotted persistent CSMA, slotted persistent CSMA. It can be one persistent, it can be P persistent. So the varieties of CSMA protocols are available, right? But one persistent CSMA is widely used in the Ethernet. Then came up with the idea of carrier sense multiple access with collision detection. Because in carrier sense multiple access, though you sense the channel, though you look at the mic, right, sometimes, right? So what will happen is there is a possibility of more than one person pressing the button, right? I have also pressed because the heat in the conference room was very high, right? The discussion was very hard. So many people have pressed the button, right, to speak at a time. Then what will happen? Everybody starts speaking. Then there will be a collision of packets. Then it becomes a noise, basically, right? In the same way, right, though the CSMA is better disciplined, but there is a possibility of two stations simultaneously, right, sensing the channel, and then they start transmitting, and then it leads to collisions. That means collisions do happen even in carrier sense multiple access. And now question is it possible to detect them as early as possible so that you will reduce the wastage of bandwidth due to collisions? That is the whole purpose of collision detection. So collision detection also has been implemented, right? Then this IEEE 802.3 standard came into existence, and this Robert Metcalfe, right? He is an important person, right? He is the one, along with his team, who is the one who has implemented the first Ethernet in 1970s, right? Early 1970s, when most of us are not born. Even if we are born, maybe we are only 2-3 years old children, right? Whereas Robert Metcalfe has practically designed and implemented this Ethernet, right? Later on, he found a company also called 3Com, right? 3Com is still available, right? It is a competitor for D-Link. It is a competitor for Linksys and other networking devices companies, right? So later on, Metcalfe and his colleague, right, they sold out this company for $400 million. And 3Com stands for Computers, Communication, and Compatibility, right? So very interesting, right? You can find his brief sketches of Ethernet, right, which he has drawn with his hand, because in early 1970s, there was no AutoCAD or ArcCAD is available to draw the circuits, right? So he has designed those circuits with his hand only, right? So Robert Metcalfe, you will find. You read a book on computer networking, a top-down approach, right? Then you will find some picture and then some words about Robert Metcalfe in that book. And the question is, why can't we use this CSMA, right? Or CSMA CD, which is widely used in the wired Ethernet till today in a wireless LAN or a DOR network, which we are trying to design. As I showed you in the earlier slides also, 802.11 definitely it has changed the physical layer. It has also changed the medium access control. That means they are deviating, or they had a doubt about this carrier sense multiple access with collision detection. We will see what are the reasons, right? Why they have to deviate from this CSMA CD. What is CSMA? Very simple protocol, right? It senses the channel. If the channel is found to be idle, then it transmits the packet. If the channel is found to be busy, right, then what it does, it waits for a random time, and this time is calculated with the help of binary exponential backup algorithm, which we call it as BEB algorithm. What are the limitations of this carrier sensing, which is used in the Ethernet, is hidden terminals and exposed terminals are not taken care in carrier sense multiple access, because these two problems are not present in Ethernet. Then what is this hidden terminal problem? Let us see this, right? That means in this hidden terminal problem, while we are trying to explain, we are assuming that we are using a carrier sense multiple access protocol with half duplex capability. With half duplex, not full duplex, half duplex capability. That means node A, node B, node C, all three are wireless nodes. All are using carrier sense multiple access, and the communication mechanism is half duplex, not full duplex, right? Colored circles represent the transmission range or radio range of each of these nodes. Right? This color is for node A, green color is for node C, and red color is for node B. Now what will happen is, this arrow indicates that B wants to have a communication with node A. So what it does, because B is using CSMA, right? So what it does, it is supposed to listen to the channel. But in the network there are only 3 nodes, right? None of the nodes are transmitting. So naturally, B will find that the channel is idle. So what it is doing, it is transmitting towards A. This arrow indicates that it has sensed channel successfully and the found to be idle, and then it started transmitting towards A. When the communication between B and A is still going on, what happened is node C has got a packet to be transmitted to node A in the same time, right? So what node C does, it is also following CSMA, right? Okay, it is also part of the same network, same MAC protocol is being used, right? So what this node does, node C also is sensing the channel, right? When it senses the channel, who is there in the vicinity of node C? You will find that only node A is in the vicinity of C, node B is outside the vicinity of node C. Hence, whatever node C wants to say, that will be reaching only up to A, not to B. That means B is not aware of C and C is not aware of B, right? So what will happen? Node C will decide, because it is not hearing the communication of node B. So the channel between C and A found to be idle. Then what it does? It starts transmitting the packet to node A. So one communication is coming from node B and one communication is coming from node C at the same time at node A. And node A's capability is it can receive successfully from only one of the nodes. But because node B and node C are hidden to each other, right? Because they cannot see each other, and node A, what is happening is both the packets are being lost in collision, because C is hidden from B and B is hidden from C. Who has done these collisions? CSMA is responsible. Right? CSMA, what it has told? First you sense the channel. If the channel is found to be idle, you transmit it, right? So both of them has followed the discipline, whatever the protocol has said. But what is happening? Because of the hidden nature of these two nodes in the wireless medium or wireless channel, the collisions are actually occurring at the receiver, not at the transmitting side, right? So this is called a hidden terminal problem. So if this hidden terminal problem is there, what will happen? This increases data packet collisions and hence reduces throughput. More collisions means less throughput, right? Probability of collisions is high means probability of success is less. Probability of success is less means more packets are lost in collision, hence the throughput will be reduced, which is not a good scenario for a network. And what is the one of the possible solutions people have suggested? Can we use RTS CPS? Request to send, clear send, handshake, that we will see in the later slides if the time permits, right? So other problem is exposed terminal. We'll see what is this exposed terminal, right? Here also you can see that there are 4 nodes A, B, C, D. We assume that they are also following CSMA, carrier sense multiple access, and communication is half duplex mode, right? Half duplex means if you are transmitting, you cannot listen. If you are listening, you cannot transmit. That means only one action at a time, either transmission or reception. That is the assumption. Now in this diagram, you can see that A wants to communicate with B. So what A does? It sends the channel. Nobody is transmitting, hence it started transmitting to B, right? That's what this arrow shows. So A is transmitting towards B, and you can see a dotted line towards C. Why dotted line? Because A's transmission, radio transmission range is this circle. So B is also coming in the circle, C is also coming into that. I told you that broadcast nature of wireless medium. That means whoever is within this classroom, whoever is connected through this through the remote centers also, they are listening to my voice, right? Because you are all in the communication range of my transmission range. So C is not actually interested in this communication, but because it is within the range of A, hence it is overhearing. This we call it as overhearing, because it is lying within the vicinity of A. Hence, actual communication between A and B, but A to C is overhearing. Now, when A and B communication is still going on, now C wants to transmit to D, right? C wants to transmit to D. Now, what will happen? C will invoke CSMA, carrier sense multiple access. So, when it senses the channel, what does it hear? It hears that the channel is busy. Why? Because it is overhearing the communication from A, right? It is overhearing the communication from A. Hence, carrier sense multiple access says to C that channel is busy, keep silent. But the question here is, suppose, right, if CSMA is not there, if C transmits to D, when A is transmitting to B, is there any problem? Actually, there is no problem, right? When C is transmitting to D and A is transmitting to B, and they are half duplex. That means when they are transmitting, they cannot listen. Then when they are listening, they cannot transmit. That means it is not going to disturb the communication between A and B, because B is away from C, right? Because B is the receiver. So if B could have been within the range of C, then there is a disturbance. But B is outside the coverage area of C. It could have been safely transmitted to C to D when A to B is going on. But who is the culprit here? CSMA told C that because the channel is busy, you don't transmit. That means you are underutilizing the channel. This channel also could have been utilized when this channel is being utilized. That means underutilizing the channel means reduction in the throughput. Channel is actually idle, but you are not using it. That's what is written here. Reduces bandwidth utilization if the exposed terminal problem is very high in the network, hence it reduces the throughput. The problem is CSMA. Other problem is all these nodes are employed with omnidirectional antennas. Omnidirectional means an antenna which radiates equally in 360 degrees, right? Hence, this node is also exposed to S communication. So one of the possible solution is it possible to use directional antennas, right? Instead of having a 360-degree antenna, can I have a 60 degrees antenna? Can I have a 120-degree antenna? Right? That's what you will see in the cellular towers, right? Instead of one antenna, there are 3 antennas. Why there are 3 antennas? Because each antenna caters to 120 degrees. So 120 into 3 is 360 degrees. That means if you use a directional antenna, better directivity and less problem of exposed nodes, right? That means your transmission direction is fixed, or it is more focused now instead of 360 degrees. Hence, exposed terminals will be reduced in the case of directional antennas. or you can also go for a separate channel for control and data. That is also possible. But we will see that what is the problem with the directional antennas. What is the problem with the directional antennas? If the nodes in the network are fixed, then it is very easy, right? Because we are talking about a mobile nodes where your host is also working like a router. It is not like your cellular tower, right? Cellular tower is fixed, but the users are mobile. That's why that 360 degrees, 120 degrees will be useful because there is an infrastructure. But here there is no infrastructure is available. Only your node is available. With that only you have to make the communication possible, right? That means the problem is finding the exact location of the node at any given point of time when it is mobile. That is number one. That means your GPS has to be perfect and it has to be real time. That means tracking the destination. Other thing is you have to steer your antenna also, right? Because you have only one antenna, right? So you have to steer your antenna also towards the destination. So steering the antenna in real time, locating the destination, right, that you are looking for in real time is a challenge, right? Otherwise, directional antennas is a good concept to reduce the problem of exposed terminal. That means any MAC protocol that you design, that I design, you have to take care of hidden terminal problem. You have to take care of exposed terminal problem. And these two problems are complementary to each other, right? If one you try to reduce, other one will increase, right? If hidden terminal you try to reduce, maybe exposed terminal will increase. If exposed terminal you try to reduce, other one will increase, right? So that means any MAC protocol that you try to design, you have to have a solution for these two important problems. Otherwise, the throughput in the network will suffer. And again, one more idea that I will give you is when you go back, right, after this lecture is over, you look at your wireless LAN card on your laptop, right? Then you will find two things. One is option for ad hoc networking, right? Another option is to enable or disable this RTS CTS. RTS CTS is a mechanism to avoid hidden terminal problem to some extent, right? That means your LAN card, which is already coming, which already you are using it, is having a provision to some extent to take care of hidden terminal problem with the help of RTS CTS enabling and disabling. That you can check it. So the earliest solution, right, for this hidden terminal problem was proposed by multiple access collision avoidance, right? You all might have heard about Qualcomm, right? Qualcomm is a leader in producing processors for mobile phones, right? Qualcomm is available in India also, right? Hyderabad they have a branch. I think in Bangalore also they have a branch, right? It is a multinational company which is a leader in cellular technology, right? Mobile phone technology, and they are producing these processors for your mobile devices. So there was a scientist by the name Phil Karn, right? Philkarn, Phil Karn. So Phil Karn, you must read this paper, right? It's very theory paper, right? There is no mathematics involved. Only some ideas he has given in this paper, right? But very interesting paper because it was published long back. So what he has done is, everybody is talking about carrier sense multiple access, CSMA, CSMA CD. It is being widely used, right, everywhere. So people thought that, and Phil Karn especially, right, he thought that, is it, PHIL space KARN, right? Either you write this or you write this multiple access collision avoidance, MACA. So automatically his paper comes up, and he is the one who took a courage, right? When CSMA is very popular, CSMA CD is very popular, it is very difficult to challenge, right? When something is going on successfully, it's very difficult to challenge. If you want to challenge it, right, that somebody is saying that CSMA should not be used, somebody is saying that CSMA CD should not be used, right? So you should have a solid idea, you should have a real footing, right, to say and to convince people. So Phil Karn could take a step that is it possible that to get rid of the CSMA, which is creating hidden terminal problem, which is creating an exposed terminal problem, as we have seen in the example. Then he told that yes, we can get rid of. So not only he said yes, but he also gave a solution, right? A possible solution is forget about CSMA, forget about CD. CD is next to impossible in a wireless domain, right? CD is already gone. CSMA also he told that there is no need to use. Then he suggested this request to send, clear to send scheme, handshake mechanism. We'll see how it is going to be useful. Right. The drawback of this scheme is how can you avoid RTS, CTS packet collisions? Though they are very small in size, control packets before you actually transmit data, but there was no mechanism suggested in that paper how to avoid these control packet collisions. Right now we are talking about data packet collisions, but here he has introduced two control packets to make the data communication successful. But what if the control packets are going to be collided? So there was no solution. But the scheme was good. So scheme can be shown this with the help of this slide in action. You can see here, right? A wants to communicate with B, right? A wants to communicate with B. So what it does? No CSMA, right? No sensing of channel. What it does? It sends a request to send a small control packet. What does this packet contains basically? It contains source address. It contains destination address. It contains packet ID, right? And it contains the duration of communication if this RTS is successful. If this RTS and CTS is successful, how much time I am going to occupy the channel, right? That is called data duration. Data duration, right? So RTS is having source address, RTS is having destination address, RTS is having a duration and type of packet. Because this is a control packet, naturally it will be having some code. So it's hardly around 20 bytes. RTS is only 20 bytes. And you all know that what is the size of an Ethernet frame? Ethernet frame is around 1500 bytes, right? Ethernet frame is 1500 bytes. And if you look at the wireless LAN frame format, it is around 2300 bytes, one frame size. So compared to the data frame, the RTS frame is only 20 bytes. So it is negligible in size compared to the data frame. So RTS packet is really small in size. Even if it is lost also, you can afford to lose it, right? So what it has done, now B has received this RTS, and what B is doing, it has replied, right, with the CTS, clear to send. What it is telling, I have received your RTS successfully. Now I am giving a clear signal to receive the data, right? So CTS has come. So you can see here, you may be wondering that why I am showing 3 arrows here, right? If A is transmitting RTS to B, there should be only 1 arrow, but I am showing 3 arrows here. 3 isliye hai because whoever is in the vicinity of A, all will overhear this RTS. And it is required also. Why it is required? Because we have to make this node silent. That means when A sends an RTS, it is meant for B because B's address is there in that, and the duration is also mentioned, right? That means B knows that when A RTS CTS is successful, so much amount of time will be utilized for data transmission. And what is the message for D and D? C and D? C and D will come to know that this packet is not actually meant for us because their address is not there. But for them, duration is very important. Duration means now A wants to communicate with some node B, right? And there is a duration mentioned in that. C and D has to keep silent for that much amount of duration so that there is no interference, there is no collision between A and B's communication. That is the purpose of this RTS is shown in 3 arrows, right? That means C and D will get the message from the RTS that B is going to receive some communication from A, hence they have to be silent for that much amount of duration, right? Similarly, in the CTS also, this is also shown, it is going to A also, it is going to E, it is going to D, it is going to A, because if you look at this circle, right, D is also in the vicinity of B and E is also in the vicinity of B. So CTS is also having a duration, right? D has already received the duration from A and E will now receive that B is going to receive something from A, so E also has to keep silent. So what will happen? These are all hidden terminals, right? So you have made all the hidden terminals silent by mentioning a duration and making this RTS CTS a broadcast packet. They are not unicast packets, they are broadcast packets. So once you make this RTS CTS successful, then A started transmitting data, right? So RTS is successful, CTS is successful, and data is transmitted. No carrier sends multiple access. A breakthrough idea, right? No carrier sends multiple access. Collision detection is next to impossible in wireless networks. Hence, collision it is removed. So hence, this is a very interesting idea that people have. Yes. Yes. So there is a question here in Chandigarh Center, right? The madam is telling that there are some flaws in this scheme also. Yes, definitely, right? One is you are making so many nodes silent, right? Because you want to avoid hidden terminal problem, right? You want to avoid exposed terminal problem, but you are compromising with the throughput. You are compromising the throughput. Maybe it's possible that some node which could have transmitted safely, but you have made it blocked, right? Because of hidden terminal, exposed terminal. But idea is very good, right? This is how the research progresses. So RTS, CTS, people have accepted that it's a good scheme, but it is not having a solution for all the problems, right? Then what they have done, one of the simplest modifications that I will show you that how the research progresses is, in the earlier scheme, there is no reliability, right? RTS is successful, CTS is successful, data is successful. This is possible only when channel is perfect. But channel do make errors. There is no channel which is perfect, right, all the time, right? Especially the wireless links. Wireless links are prone to more errors, right? So is there any possibility to increase the reliability of data transmission? So what they have done in MACA-W, right? Very good, right? RTS is there, CTS is there earlier, data is also there. What they have done, they have added only one acknowledgement. That means every data packet that you transmit, you must get an acknowledgement. By just adding this ACK, right? And one more new research, right? A new idea. That means to improve the link reliability, you have added one more control packet in the name of ACK, right? That means it takes care of transmission errors, which is done by the channel, which was missing in the earlier MACA, right? This is MACA-W with along with some more changes they have done. Okay. What is it, right? Okay, remote center, right? Now the time is 4:10. Slides are many, right? Okay. I think I have around total 82 slides, right? We are at slide number 38, right? Almost around 50% range. So, right? So, we will stop here, right? Further, we have slides on MAC protocols in detail, right? Maybe I can just rush through quickly so that you can get an idea, right? What all things are there available in this. Just I'll show you 802.11, right? So we have seen CSMA. We are convinced that collision detection is not possible because of hidden terminals and exposed terminals and the signal strength variation, right? Which is not a factor in Ethernet, right? So because of signal strength variation, because of hidden terminals, because of exposed terminals, collision detection is next to impossible. So CD is removed, but Philcon has suggested even CSMA also can be removed and you can go for RTS, CTS. And what IEEE has done is it has taken together. CSMA is very lovely, right? Because it is being used for more than 45 years. So they don't want to get rid of it because CSMA is the brainchild of IEEE 802.3 committee. So they don't want to get rid of this CSMA. So CSMA, they have retained it, right? CD is removed because it is not possible to have collision detection. But they have also considered the case of Philcon, that is MSCA, RTS, CTS. So what is going to happen? You have two schemes they have given. One is called carrier sense multiple access with collision avoidance. If you cannot detect collision, is it possible to avoid by some means, right? So CSMA CA is the basic access scheme. But if you have a hidden terminal problem in your network, you can also disable this RTS CTS, right? So CSMA CA is a network which doesn't have hidden terminal problems. You can use this CSMA CA. If a network is having hidden terminal problems, or if you feel that your throughput is suffering, then one of the reason could be hidden terminal. So enable this in the card, RTS CTS, right? So you have CSMA CA without RTS CTS. You have CSMA CA with RTS CTS, right? And you can see the working of it. That's what is explained in these slides, right? Finally, CSMA CA with RTS CTS is successful in transmitting a packet using this particular protocol. But this protocol is also having certain limitations, right? It cannot avoid hidden terminals completely. It cannot avoid exposed terminals completely. Hence, there is a need for further research, and people have done many things. When you look at the literature, right, a lot of things have been suggested, and you must see it, right? And RTS, CTS packet collisions are still existing here. This slide is important. Just I'll explain you, right, how RTS, CTS collisions are going to occur. A is transmitting to B RTS, right? Okay, CSMA is over. RTS has been transmitted. So by the time what will happen? This CTS, right? When B is transmitting to CTS, because B and C are in the vicinity of each other, right? That means these circles indicates that A and B can communicate directly. B can communicate with A also, with C also, right? In that case, what will happen when B is transmitting to C and this CTS reaches to C also? But when this CTS is coming to C, D, which is not in the range of B, right? What it has done? It was sending an RTS to C. So what is happening? RTS of D and CTS of B are collided at C. So this is an example of RTS CTS packet collision. CSMA was there, carrier sensing you have done, RTS you were transmitting, CTS was coming to the source station, but at C there is a problem, right? RTS and CTS from two different modes have collided. Similarly, you can also show RTS collisions. You can also show CTS RTS collision. You can also show CTS RTS collision. So this cannot be avoided. That is a difficulty in the simple CSMA CA with RTS CTS cable. Then so far whatever MAC protocol that we have seen, like pure Aloha, slotted Aloha, MACA, W, right, and then this IEEE 802.11 MAC DCA protocol, all are single channel MAC protocols. Now people are talking about, is it possible to go for multi-channel MAC protocols? Multi-channel means divide the available bandwidth into multiple channels and select any one of the idle channels, which was not possible in the single channel. What is the advantage? It improves the throughput performance in the network because you have divided one channel into small channels more than one, but the difficulty is hardware complexity because you have to divide the channels and the station has to identify which channel is free, right? Whether the channel 1 is free, channel 2 is free, or 3 is free, or 5 is free. So that hardware is also required to identify the channel. That's what you can see in this diagram. So this is an example of single channel multi-channel MAC protocol, right? These three nodes are in the radio range of each other, A, E, and C, right? If it is a single channel MAC protocol which is being used, right, between A and B, C and D, and E and F, what will happen? Because these three nodes are in the communication range. So communication we are talking is A to B, C to D, E to F, right? So when A is transmitting, C and E cannot transmit because they are in the range of each other. When C is transmitting, A and E cannot transmit. When E is transmitting, A and C cannot transmit. That's a single channel protocol. But when I go to a multiple channel protocol, I have three channels, right? So one channel I use for A and B, one channel I use for C and D, and I can use E and F another channel. That's what in this diagram you can see that at a time there is only one communication. Either PAB is there, or PCD is there, or PEF is there. But whereas in the second one, you can see that all are parallelly going on, right? Overlapping. That means bandwidth is better utilized, but the problem is how to identify. The hardware complexity is required, necessary hardware is required to identify which channel is free. That means you have to select that particular channel, right? But there are a number of protocols people have designed with the help of multiple channel MAC protocols for ad hoc networks also. Then other concern is directional antennas, as I told you, right? Instead of going for omnidirectional antenna, you can also go for directional antenna to reduce the problem of exposed nodes. So here you can see in this diagram, right? C and D are actual communication nodes, right? And you can see that all these red color nodes are blocked, right, by RTS and CTS because omnidirectional antennas. Now, if I use the directional antennas, right? Directional antennas means C's direction is like this, right? E's direction is like this, and X direction is like this, and D's direction is like this. That means if any node is within this circle, right, then only the signal will reach. Otherwise, it will not reach. In the earlier diagram, all these nodes were blocked, but in this diagram, only B is blocked. That means number of exposed nodes you have reduced by designing a directional antenna, right? But for a static nodes, excellent solution. For a mobile nodes, you have to exactly locate the destination node, and then you have to steer your antenna. That is a difficulty, right? And that's an expensive solution. Then other one is energy conservation. So energy conservation can be of two forms. One is power save, other one is power control. Power save means turn off wireless interface whenever is not required. Just like your laptop, right? If you don't use it for some time, if you have configured, automatically this screen will go into sleep mode. In the same way, wireless interface also can be put off when you are not communicating, when you are not receiving or transmitting energy. Other one is power control, right? Power control means you decide how much power is required to reach to the destination, and accordingly you choose the power level. This is what you can see in this diagram, right? In the original diagram, you can see that there are 4 nodes here, right? C wants to communicate to D actually. Let us say D or B. So what is happening? It is using the standard power. By using the standard power, what is happening? It is also creating some exposed nodes. That means suppose if it is talking to D, but B is also exposed, right? But if C is smart enough to identify what is the power required to reach to D by some means, right? Let us say C sends a pilot packet with some signal strength. Suppose it receives successfully the reply from D, right? Then it can decide that only this is the amount of power that is required, right? Then it sends another power, one more control packet, right? In that also it has got received an alarm. So then you can decide the power, right? How much power is required to exactly receive to the D, right? On a testing basis, right? On a pilot basis, you can decide what will be the signal strength that is required, what is the transmission power that is required to reach to the D, so that you will create minimum interference, minimum exposed modes in this particular system. But the difficulty is what should be the optimum power to reach to D has to be calculated. That is a challenge, right? If you can do it, then you can be successful in saving the power. So if you can't save the power, you can turn it off also, right? So your two options are available. So power saving protocols are also very important. Energy efficient MAC protocol. That means you can work on energy efficient MAC protocols. You can work on directional antenna based MAC protocols. You can work on single channel MAC protocols or multi-channel MAC protocols with a focus on hidden terminals and exposed terminals. A lot of work has been done, but still people are working on the various. You can think of quality of service, right? Quality of service also you can think of. You can also think of scalability, right? If there are 10 nodes are there, how well your MAC protocol behaves. But if I have 50 nodes in the network, does it give the same performance? Does it give a required performance? That is also a challenge, right? So we'll stop here because then after that you have slides on routing protocol, transport protocols, and all those things. So we'll stop here. Though I have rushed through the slides, right? So any questions? Quick questions.
Yes, sir. One question. So finally, which protocol is currently being used in 802.11 wireless LANs, etc.?
It is being used as CSMA CA with RTS CTS with the option to enable disable RTS CTS.
Okay, sir. And currently they are using multiple frequencies or single frequency?
It is right now only single frequency.
Okay, sir. Thank you.
Yes, why not, right? There is a question here. Is it possible to think about an array of directional antennas? Yes, right. I am asking about only one directional antenna, and he is talking about multiple directional antennas, right? Array of directional antennas. Yes, it's possible. But only thing is, how will you take care of the mobility aspect? If your nodes are going to be static, yes, definitely it is going to be very useful. Even a single directional antenna is also very good because your nodes are fixed. But when the nodes are going to be mobile, then this a challenge comes. Good idea. Yes. Welcome. Welcome. Yes. Welcome. So you have issues of energy efficiency, quality of service, then scalability, right? Then directional antennas, hidden terminals, exposed terminals, completely elimination, right? Any scheme, right? And then security, definitely, right? Security is also one of the issue, right? Though the security which is available in 802.11 is very robust now because you have WPA, WPA1, WPA2, TSK, right? All these schemes are available, but still people are working on security mechanisms. So if there are no questions, then we will.
Sir, one last question.
Yes, sir, definitely.
In the previous session, Mr. Saurabh gave us some demonstration, and he was showing us the actual traffic and what is happening on the network interface card, wireless network interface card. And in that, we were able to see multiple MAC addresses for multiple channels.
Right. Multiple MAC addresses because there are different systems traffic is going on, right? He was showing you MAC addresses of different machines.
No, sir. One single machine had at least 10 MAC addresses. Like there was only one network interface card, but there were 10 MAC addresses, and it was showing different channel numbers. And I asked that different channel numbers would be probably different frequency bands to communicate. So now I have one contradiction here.
No contradiction is there. see, you yourselves are saying that there are 10 MAC addresses and then 10 different channels, right? That means all are different. See, in the wireless LAN also I told you, when you talk about a 2.4 gigahertz, right? I'll just show you that slide, right? There are 3 non-overlapping channels, right? That I also showed you. So there is no confusion for you, right? We'll remove your confusion. Yeah. This slide, when you look at it, right? Is it visible to you? So you can see here, let us say 802.11. We are using a 2.4 gigahertz to 2.4835 gigahertz channel bandwidth, right? There are 3 non-overlapping channels. I am sure that you have understood what is the meaning of non-overlapping channels. In a 83.5 megahertz, there are only 3 non-overlapping channels. That means when you look at the bandwidth, right, the starting frequency and ending frequency, each of the channels, they are independent, right? They are not overlapping one another. That means I can run in this 2.4 gigahertz in a single campus 3 wireless LANs without any interference, without any overlap. It doesn't mean that it is a multi-channel MAC protocol. I am talking about single network using multiple channels. Single network using multiple channels. That means only one channel I am taking out of these 3 and I am splitting that one channel into maybe several parts. I am talking about that. So what Saurav might have shown is, he might have used these 3 or maybe 10, right? Because actually there are 14 channels are available in 2.4 gigahertz. So he might have shown you that, right? Each MAC ID is having one frequency channel. That is fine. But I am not talking about that. I am talking about only one network in this entire NITRR, but I am talking about only one channel that splitting into several parts and utilizing it. Is it clear?
Sir, my question is something like why one network interface card was having 10 MAC addresses? That I did not understand.
That is not a one network card. You might have utilized some simulator or something you might have shown, right? So it is not possible that one network card.
He had a wireless card from a company known as Alpha, and it was advertising 10 different MAC addresses with different channels available, and different channels were probably different frequency bands, I guess. So
you just listen to me. Frequency band, if it is a 802.11b or G card, frequency band is fixed 2.4 to 2.4835. As I told you also, there are 13 or 14 channels, overlapping channels are available, right? So you might have shown you with that card that it is choosing different frequency channels, right? That is possible, right? That any access point can do, any of your LAN card also can do it. But at a time, it cannot choose multiple frequency. It can choose only one frequency, which is available, which is free. That is possible.
So multiple channel MAC protocols, which we discussed, is not using different frequencies at the same time. It should use, and the communication would be much better.
Yeah, that's what I'm telling. It is a multiple channels are available in this 2.4 to 2.4835 gigahertz bandwidth. But the problem is you can use only one of the channels, not all of them. My question is it possible that if I am using, suppose, a channel number 1, any node which is in my vicinity, can it use channel number 2 or channel number 3? Right?
Okay, sir.
That is the thing. Thank you, right?
Thank you, sir. Thank you.
Right, thank you so much, right? All the centers. Thank you.
Hello, GSS Academy. Can you hear us? GSS Academy. Dr. Seema Shukla. Hello.
Hello, sir. Hello.
Hello. Yes, sir.
Yes, sir. From JSS.
Number of participants you center, sir?
32. Hello.
Fine. And sir, you do tomorrow?
Hello?
Yes, sir.
Older enough for me to answer. ବନ୍ଦ କଥା ହେଇଯାଏ ନା କେତେ ପଚାରିବେନି ଆଉ କିଛି କୋଶ୍ଚିନ୍
ସେ କହିଲେ କ୍ୟାନ୍ସେଲ ବାକି ରହିଯାଇଥିବ ନା ତାର
ସମସ୍ତେ ଗୋଟେ ଗୋଟେ ବନ୍ଦ କଲେ ବନ୍ଦ କରିଦେଲେ ସେ ସମସ୍ତେ ଗୋଟେ
Okay, tomorrow we'll meet at 9:15. All remote centers. Session will end.
Okay, sir, no problem.
अभी स्ट्रेंथ दिख रही है ना, देखो स्ट्रेंथ कितनी है अभी. गुड.
गिन लीजिए सर, 50 के आसपास होंगे.
सर कम से कम दिखना चाहिए. ऑडियंस 3 center is restricted. Okay, sir. Thank you.
Okay, thank you so much.
Thank you, sir. Thank you. Okay.
Thank you, sir.